Good morning, everyone. We will start in 2 minutes. For those of you who are spread out around the hall, we kindly request if you can move forward. We have a lot of seats with good view up front. Thank you. Ladies and gentlemen, good morning. May we request everyone to take their seats as we begin day 2 of the forum. We hope yesterday's discussions inspired collaboration and meaningful reflection. For our first session for today, it's session number 3, Innovative Plastics Upcycling. To guide today's exchange, we welcome our moderator, Ms. Selina Horak from the IAEA. She is the head of the Radiochemistry and Radiation Technology section and one of the scientific secretaries for this forum.
morning, everyone. I'm sorry for the technical issues. Well, welcome. I'm very honored to start with the first session of this morning on this high-level forum on the NUTEC Plastic Initiative. And this session actually is going to show the success story on this long journey of the NUTEC Plastic Initiative in the upcycling components. As has been mentioned by the DG Rossi at the opening session, the NUTEC Plastic Initiative has two components, two prongs. One on the marine monitoring and how to track the microplastic in the marine environment, and also how to use radiation technology to upcycling plastic waste and reuse natural resources for bio-based application. So today in this session we will explore how colleagues from different parts of the world has implemented this activity, especially using radiation technology to create value from plastic waste. So the panel that is joining me now, and I'm the pleasure to moderate, is showing success story from Argentina, from Malaysia, from Philippines, and a partnership between Germany and Romania. And then at the end, we will have the chance to learn a little bit more of one of the toolkit that has been developed through this also NUTEC Plastic Initiative on how we can assess the economical and circular economy aspect of this technology when it's being integrated into the waste management. So allow me now to introduce our first speaker, Mr. Franco Frola, who is the co-founder of Circularis, the private partner of the Argentinian team. Franco is an Argentine entrepreneur who develops circular economy projects with local and global impact. And well, he has the passion for sustainable development and focus on creating innovation that foster innovation, environmental progress and socioeconomic growth. So the floor is yours, Franco.
Hello, hello. Thank you, Elena. Hi, good morning to everyone. Before I start, I will say thank you to Selena and all the staff of the agency to make this forum. NUTEC Plastics for entrepreneurs like us is a place to connect and expand, and thank you to make this a real high-level forum. To start, I have a video, so if we can run this. What? To speak today, I will try to have three ideas will guide us. Prevention, scalability, and synergy. These concepts condense 8 years of work and many more of experience into a few minutes. I'm Franco Frola, CEO of Circularis and co-founder. A startup is based in Córdoba, Argentina. My colleague Verónica Bock from the National Atomic Energy Commission of Argentina was unfortunately unable to come to Manila today, but she sent her regards. And for me, it's an honor to be here with all of you. And now we will start with prevention. As you saw in the video, imagine a railway sleeper made mostly from recycled plastics. Strong, durable, and cheaper to maintain than wood, serving trains for decades. Now imagine it starts as a packaging waste. Today, I will show how radiation upgrades recycled polymers so they meet structural demands. And continue with the prevention, we thought if we want to avoid plastic island in the ocean, we have to act upstreams, stop leakage before plastic reach rivers. That means better collection, and crucially, high value end uses for what we collect. But all of us know the recycled plastic often falls short on resistance, strength, and other properties. That's why for us, prevention starts with performance. We improve the mechanical properties of recycled plastics so they meet construction demands for public and private infrastructure projects. In the second place, I want to talk about scalability, because this project can be replicated in different regions and countries. This concept is most clearly demonstrated through three drivers: market demand, the technology, and the plastic we recover. On market demand, our clients are companies of transportation, housing makers, electrical and telecommunications developers. These industries have constant high volume needs, which lets us to pull a lot of plastics. On the technology, the machines designed especially for us and the electrobeam technology are modular and installable anywhere with the ongoing support of our teams. And the last one, on materials, we develop multiple recipes with polyolefin blends. This helps us to recover a big portion of mixed plastics. And this is a very important thing, mixed plastics. And the last one, and for me one of the most important, synergy. And this is where public science and industry application meets. The National Atomic Energy Commission brings nuclear and e-beam know-how and a highly qualified team with many years of experience. Circularis brings recycling expertise and structural product development, turning diverse waste streams into a real heavy-duty products. In short, public science, industry experience working together with one playbook. That is the synergy. And to expand that synergy, we invite all of you to join our mission. Together, we can replicate this model in multiple countries, absorbing more plastic pollution. For us, when materials improves, recycling expands, and rivers and oceans stay cleaner. For global challenges, local solutions. Let's get together to work together. Thank you.
Thank you very much, Franco. Now, with this excellent highlight of how the work of this partnership can achieve the result of having the railroad for more durable and stable product for the train company, we will move now to the next speaker coming from Malaysia. So we have now a partnership who will demonstrate how through this collaboration they could also achieve very success result. So please, Mr. Ting Teo Min and Mr. Ahmad Lukman bin Mohammad Adam. Teo Ting is the manager of the Polymer Composite and Recycling Group at the Malaysian Nuclear Agency, working in radiation modification and functionalization of polymer material, and he leads the project in the radiation-assisted polymer recycling. On the other hand, Ahmad Lukman bin Mohammad Adam is a dynamic mechanical engineering professional who has rapidly advanced in the energy sector and is rising on engineering apprentice to CEO of the Mensil Green Energy. Mr. Malaysia team, the floor is yours.
Yeah, thank you, Ms. Selina Horak. Good morning to all panelists, distinguished panelists, our colleagues, and all participants. So my name is Ting. I'm from Malaysian Nuclear Agency. And today it is an honor for us to participate in this high-level forum. And then together with my partner, the CEO of Mesilins, Mr. Ahmad Lokman, so we are sharing. We are sharing today our work on the chemical recycling of waste plastic enhanced by radiations from Malaysia industrial perspective. We of course acknowledge because this project basically is under the NUTEC Plastic Initiative, and the progress that we are able to be able to share today by all the member states, it's very much reflects the contribution from, for example, from Ms. Selina Horak, as that reflect the commitments as well as the leadership that we are able to, to make the progress by moving it from the concept or the idea into real on-the-ground executions. Okay, so the plastic waste situation in Malaysia is quite actually challenging because we produce 50 million tons of plastic waste. That represents around 40,000 of tons being discarded on the daily basis. And from these, we have around 10% plastic waste. And the problem is that the recycling rate in Malaysia is low. And due to that, we are expecting to reach full capacity by the year of 2050. So therefore, the technology, the solutions to provide the strategic solutions on this aspect is very much needed, as well as the recycling efficiency. So imagine in a world where every single pieces of plastic waste is not a burden to us, but rather resources for us to fuel our tomorrow. So that basically we'll be able to transform the end-of-life plastic into a clean and value-added fuel. So the perfect, for example, in Malaysia, as an example, we do support this off-grid user in various industry. And this, if we are able to do that, we actually can reduce the pollution. And not only that, we also can reduce the fuel fossil dependency. So against plastic waste management in Malaysia is rather complex as well as multifaceted. Firstly, is on on the plastic waste consists of a mixture of plastic waste, and it is difficult to recycle. In other words, the cost to recycle it is high. And secondly, most of the chemical recycling required very high energy input. And thirdly, the market and technology gaps. So this reflects that in order for you to convert the low value plastic into the high value product. Okay, but then this presents the strategic opportunity to us. Whatever technology that we're able to introduce, it basically support the Malaysia circular economy blueprint, and our aim in this policy basically is to increase the recycling rate to at least 40%. And if we're able to scale up this circular solution, that actually represents that it has the opportunity to create at least 10 billion of economic impact to Malaysia, as well as 50,000 green jobs. And all these initiatives support the global priority under the Alliance to End Plastic. For example, even we is supporting the SDG. So this is the concept that the existingly being introduced by Michelin on the plastic to fuel, where the plastic waste is converted to the green diesel by using the thermal gasifications with the catalyst. So our aim basically is to integrate the radiations technology into this technology. Basically is to enhance the breakdowns as well as to increase the yield and overall efficiency. So this is where we are intended to introduce the radiations into the with the aims to produce the pyrolysis oil. So in the laboratory scale, first step, of course, is to do the pre-treatments, then followed by electron beam. The electron beam basically is to enhance the breakdowns, and followed by the pyrolysis to treat the plastic waste, and the gases or the vapor that is produced from the pyrolysis will be undergo the condensation systems to produce the liquid oil. And after that, the oil that is produced, we characterize and we analyze the quality of the oil that is produced. So this is the results on the TGA and the DTG. So that basically reflects the shift of the temperature from high to low temperature, and on the bar chart upper there, that actually reflects the yield. So after the radiation introduced, the yield was increased, as well as the solid compositions was also reduced. In terms of the energy consumptions, we convert it to per kilogram. So that also reduced in terms of the energy that is being input into the pyrolysis system. So this is a summary. So at 50 kilogram, we achieve the low solid residue, as well as a yield of almost 80%. So we actually started these collaborations not even before we start our laboratory work. We actually establish our connections or collaboration with the industry first. So after that, only we started our laboratory work based on the demand from the market. So first, we have a collaboration with the FS. It's a company that collected municipal waste. They provide the municipal streams of the plastic waste to us, and after that, we process at nuclear measure, and we delivered this to Michelin. So at this point of time, I would like to hand it over to for our second part of introductions by as represented by the Michelins, to further explain on the downstreams conversion technology, as well as the commercial deployment.
All right, thank you so much, Dr. Ting. Nuclear Malaysia has been our partner on this radiation, and it is quite what you call exciting on this journey. So, what does our technology do? We cut the hydrocarbon chain of polymers into the hydrocarbon chain of diesel fuel, which is around C10 to C15, and with a low temperature. So that is where our niche whereby this is how the process works. Means that we have three phases. First is the feeding process. The intermediate phases is the catalytic depolymerization process. This is what our pattern are. And the end product is 80% conversion. So means that for every 1 kg of plastic, you can actually get 1 liter of diesel. Aside from that, we also get light fuel oil, which is around 5%, and 15% residue. This residue is actually carbon black, and we already have a market in Malaysia and all over the world. And is it better? Does our green diesel is better? Yes. We have compared with our commercial diesel, Petronas diesel. In terms of mileage, we save around 6%, and in terms of sulfur, we are lower. And it does reduce the carbon monoxide and carbon dioxide emission by 30.8% and 2.82%. And what our target with nuclear radiation is that right now we already achieved Euro 5 diesel fuel. But what we wanted to get is a new value-added product. Can we actually get a kerosene or jet fuel or also naphtha? So naphtha, if we can get naphtha, we can convert it back to plastic. If we can get jet fuel, we go for aviation. For the residue, we are targeting to get what you call a further R&D to produce graphite and graphene. If we will achieve to successfully produce this, we can actually enter the semiconductor industry. And this is our ready-to-go project in Malaysia. We need a capex around 5 million US. But if we were to do in Philippines, it's around 8 million US. And yeah, in Malaysia is already ready to go. In the Philippines, we need to do some legwork first. Some of our track records, we met with a lot of ministers. We went to Vietnam. We got prizes from competitions. And we also have exported our diesel fuel to Thailand. We got the excise of Thai to certify that our fuel is a high-grade, low-sulfur diesel fuel. And this is what our target for our technology. We wanted to produce a net zero waste total solution. So it means you use plastic waste, all of the things that you get from it is product, which is diesel, naphtha, jet fuel, and also graphite. With that, I thank you.
Thank you very much. I'm very excited result and based on the result, what the potentiality that this technology has. So now we will move to our next and local speaker team, the Philippine team, and who is, please, Mr. Jordan Madrid, who is research specialist at the Philippine Nuclear Research Institute. He has specialized in ionizing radiation and the beneficial application in the environment, energy, and industry domain, and is the project leader in this PREX plastic project. And also his private partner, Mr. Winchester Lemon, President and CEO of Envirotech Waste Recycling, who is the private partner of this project and is specializing in mixed soft plastic waste to product and extended producer responsibility. So, Mr. Jordan, Mr. Winchester, the floor is yours.
Thank you so much, Selena, for that very kind introduction. All right, again, good morning to everyone. It is an honor to be here and to be part of this panel and to contribute to the very meaningful discussion on the topic of how nuclear radiation science technology can contribute to mitigating the plastic pollution problem. So allow me and my partner, Engineer Lemon, to present the Philippines' contribution to the NUTEC Plastics Project. Okay, so to put things into context, we are here and we meet at a pivotal moment. I think globally the plastic waste problem has evolved from a visible environmental issue into an urgent global systems challenge. And from the studies supported by the Philippine government, by both the Philippine government and the Asian Development, and the World Bank in 2019, the results of that study underscored the scale of the problem. So unfortunately, our recycling efforts are overtaken by our linear plastics consumption patterns, with only 28% of the consumed key plastics being recycled, thus requiring the production of more virgin resins for industrial applications. And for countries like ours in the Southeast Asia, the materials, these plastic materials are the backbone of our daily life. Like we use sachets, we use flexible packaging, we use films. Unfortunately, they are also the most technically difficult to recycle. And due to that, we know that they have negative effect to our ecosystem. Like they clog waterways, they contribute to flooding, and they threaten marine ecosystems. Yet, in the challenge that I just described lies a very remarkable opportunity, one that my team at the Philippine Nuclear Research Institute would like to take advantage of, and that is to use this plastic waste as resource, just like our previous speakers from Malaysia. We would like to see them not as trash, but rather as feedstock for different manufacturing processes. And that is what NUTEC Plastics is all about. It basically, the NUTEC Plastics initiative of the International Atomic Energy Agency is enabling that project. And the Philippine government, through PNRI and ITDI, we are advancing that project through our PREX plastic activities. And so the post-radiation reactive extrusion of plastic wastes, or our project, we call it PREX Plastic. It demonstrates something which is transformative, that we can use electron beam or EB irradiation to re-engineer our post-consumer and post-industrial plastics at the molecular level. And that is being implemented without using additional chemicals and without high temperature catalysts. And through electron beam exposure, we induce changes in the molecular level in recycled polyethylene. And through that, we tailor its architecture prior to melting and mixing with the polypropylene wastes through the extrusion process. And through this, we enable heterogeneous waste, like the combination of polypropylene and polyethylene, which in literature and many industries, they consider these blends as unrecyclable. But in this project, we blended them to make them stronger and convert them to more durable construction materials. And we are really fortunate that our vision of converting plastic waste into construction materials without using additional chemicals and without using high temperature catalysts is being shared by our private company partner, Envirotech, Waste Recycling Incorporated. And together, we are advancing a common goal. We want to convert plastic wastes, some of them irradiated with electron beam, into high-quality construction materials. And after we've converted them, we want to deploy these materials in real structures. And most importantly, we would like to ensure that at the end of their useful service life of these construction materials, that they can be recycled again with minimal complications. And because our process relies on electron beam modification without chemical additives, we preserve this recyclability. Now, we would like to emphasize that we are not replacing industrial practices. We are contributing to upgrade the existing industrial practices. And we are not working in isolation in this project. This progress, the progress of the project, is made possible through the IAEA's NUTEC Plastics Framework, which brings together science, technology, and international cooperation. Now, what excites me the most, of course, as a researcher, as a scientist, I'm very much a fan of like getting fancy data in the laboratory. But again, what excites me the most is the potential real world impact. So we have demonstrated in the laboratory and in upscale processing that the composites that we produced have improved mechanical properties. And we have collaborated with Envirotech for industrial scale runs. So we already translated our lab scale data into real manufacturing line test runs. And soon these materials will be used to build a prototype house. I think some of you will visit the house this afternoon. And our hope is that through that prototype, we can showcase, by the way, that prototype is still an experimental, it's part of the big experiment because we would like to see the structural performance of this construction materials built from plastic wastes, how they withstand being exposed to the different elements. But basically that will showcase how nuclear-enabled recycling can transform low-value plastic waste into building components. Now, our vision is simple but ambitious. We would like to, of course, through this project, we would like to see radiation-enabled recycling hubs serving Philippine industries. And we would like also to see circular value chains that turn plastic waste into building construction materials, into infrastructure. I would say that PREX is not the end. It is the beginning, perhaps a prototype of how nations can leverage nuclear science, radiation science, and technology to close the plastics loop. And with that, I would like to hand over the microphone to someone who is turning this vision into real industrial momentum, my partner, Engineer Winchester Lemon.
Good day to everyone, the panelists and Ms. Radina. I speak not from the laboratory, but from the factory floor and from the communities whose waste streams we handle every day. As a recycler, I live that the realities that Dr. Jordan Madrid just described. The plastics that dominate our waste, sachets, films, multi-layer packaging. It has been difficult to recycle at scale. However, at Envirotech, we have developed the process to recycle this plastic waste to make chairs, tables, pots, just to name a few. We can also recycle bricks, tiles, but then we collaborated with PNRI under DOST with the hope to strengthen the construction materials without using chemical additives. Our vision aligned with the PREX technology that could bring about the required enhancement without chemical additives and via processing at mild conditions. This opened other avenues for recycling plastic waste, particularly the high-density polyethylene and the off-grade polypropylene waste to maximize economic benefits. And this is why PREX and NUTEC plastics is very important. They do not simply introduce a new technology, they change the economics of the plastic waste. Test runs were carried out in our facility for 3 times, wherein irradiated HDPE were brought by the PNRI team, mixed, extruded, and molded to sample specimen at our factory, and tested at a third-party laboratory. When we tested irradiated polyethylene and polypropylene blends with PNRI, we saw significant improvements in the compressive and flexural strength of the materials. More importantly, the results obtained across a year of continuous testings are reproducible and consistent. ensuring unstable and higher value output. This is what industry needs: reliability, scalability, and a clear business case. The project emphasizes that technologies like electron beam modification allow us to collect or purchase low-value plastics and upgrade them into a premium grade. That means new revenue streams, more jobs in sorting and processing, higher purchasing power for waste pickers, which is very important to us, lower emissions and reduce landfill pressure, and products that complement and even compete with virgin plastic, wood, and potentially concrete. This is the kind of circular economy people talk about in global forums. And we now have a clear example on it on the ground, which you can see later in Quezon City. What makes PREX work is not just the science, it's the partnership. Government researchers bring world-class expertise, international guidance through NUTEC plastics, and private industry turning innovation into real products and livelihood. Market incentives under the extended producer's responsibility can also catalyze and support these endeavors, with a clear shift from waste disposal to resource manufacturing. Continuous support of ionizing technology research, development, and innovation, and with coordinated support, radiation-enabled recycling can scale up much faster than traditional approaches. Investing in EB recycling is not only an environmental act, it is a competitive industrial strategy. Countries that can adopt it early will create new manufacturing value chains like boards, tiles, planks, and other outdoor materials that are stronger, cleaner, and more sustainable. This is a growth factor. Demand for sustainable construction materials is rising, and technologies like PREX give recyclers the consistency and the quality assurance needed for long-term contracts. Plastic waste is a global problem, but solutions must be local, scalable, and economically viable. PREX and NUTEC Plastics show that when science and industry join forces, we can transform the world's most challenging waste into opportunity and value. This is not just recycling, this is reinvention, and it is the only beginning. Thank you very much.
Thank you very much, Jordan and Winchester, for showing us the success achievement, no, through this long journey. We will have the chance this afternoon to see the final product, that is the house made of recycled plastic. So I'm very excited to see that, the big baby. So now we are going to move to our standalone, but no alone really, expert, no, Uwe Ghost, who has collaborated also with the Romania team, a private company, in developing a strategy for increase the quality of raw material from plastic waste. So Mr. Uwe Ghost is Chief Consultant of Stericon Ghost Sustainable Technology for Research and Industry, has been supporting IES since 2019 as an expert, no, collaborating this NUTEC Plastic Initiative from the very beginning, and also in designing actually the NUTEC Plastic Initiative. He has collaborated with us as also in the one-to-one collaboration when to support the country in developing and advance in the progress that is needed. So he's expert also in polymer blends, biopolymer and sustainable reactive processing, in recycling of plastic waste, and is senior researcher on EV technology. Uwe, the floor is all yours.
Okay. Many thanks for your kindly introduction. Dear delegates, dear friends, it's our pleasure to present our results for the electrostatic sorting. When we are thinking on the projects for NUTEC plastic, then these are not scientific projects. These are application-oriented projects. That means we are looking to install a demonstrator. And as my colleagues have already mentioned, we need the request from the market. That means the best conditions we will have when we are looking for a company. And not only a company, it should be a company which has experiences in making plastic products. This company should have experiences in doing the recycling, and the company should also have experiences in the market. This means how the company can earn money. The company is not allowed to waste money. So, and we found the company Monofil from Romania. I have a very long collaboration with my colleagues. Unfortunately, it was not possible that they can join the meeting, but I will try to introduce the company to you. This is a company which is producing PP-based composites for different applications. They are also filled. This company is also using biopolymers for the production of packaging material. That means this company is going on the way to circular economy. And when we are looking here, you can also see that the company is already doing the recycling. And as a company is using polyolefins like polypropylene and polyethylene, this company is also interested in doing the sorting of polyolefins. That means polypropylene and polyethylene. But when you are looking at the market, there is no technology which will work for mixed polyolefins. And this was a starting point for our collaboration. And the motivation is the following. On the market, you will only find a small amount of sorted polyolefins. But when you are looking for the application, you need a good volume of plastic waste in order to produce your products. When we are changing from virgin polyethylene and polypropylene to plastic waste, we can reduce the price by about $1,000 per ton. And this is a good option. And further, we can also reduce the global warming potential from roughly 1 kilogram CO2 equivalent per kilogram plastics we produce to roughly 0.2 kilogram CO2 equivalent per kilogram plastic we have proposed. That means this was a starting point, and now we have to think on radiation-induced sorting, and when we are looking to these processes, as my colleagues have already shown, there are two options. The first option is the chemical recycling, and the second option is the mechanical recycling. In our presentation, we will show you a very simple effect. When the electrons are interacting with polymers, they are also transferring their negative charge. That means during an electron treatment, we are charging the polymers. And this was the idea, this was the beginning. And we did a study. That means we did a proof of concept. We irradiated virgin polyethylene and virgin polypropylene with a dose of 7.5 kilogram, and we started with a volume treatment. At the end, we were able to show that we can separate, by using the electrostatic separation, the LLDPE from the polypropylene. But when we are thinking on the integration, that means the use of this technology inline for the company Monofil in Romania, then we have to see that the local shielded 0.6 MeV electron accelerator is very huge. Further, we have to install a special storage system, because when we are doing the electron treatment with 0.6 MeV, we have to wait at least 2 hours to start with electrostatic sorting. But the new approach will be that we can change the energy. But before we will go to this, we did an evaluation of our scientific results. And we used the e-beam tool, which was designed by my colleague Enrico Mazzoli. This is a very useful tool. You can roughly calculate the production cost of your new process, and you can compare it. And as you can see here, we did a comparison for Germany and for Romania. And as you can see, the conditions are much, much better in Romania compared to Germany. This is very easy. We in Germany, we are too expensive. Our salary is too high. So that's why we decided to do this project with a company from Romania, and using this e-beam tool, we applied for a funding from the European Union, and we passed. That means we got this funding, and the task was that we have to reduce the energy of the electrons from 0.6 to less than 0.2 in order to have a surface treatment, because a surface treatment is more sensitive to the discharging of the charged polymers. We have to reduce the time between the electron treatment and the beginning of the electrostatic sorting to roughly 5 minutes. And the option was that we will be able to integrate this new facility into the application. Here you can see the first results of our pretest. You can measure the transferred charges by a field meter, and the field meter is giving you a voltage, and the voltage is negative because the charge of the electrons is negative. And as you can see there, we have used plastic waste from the company Monofil. You have different behaviors of the charging and discharging. And this is the point where we can start with our electrostatic sorting, and it's roughly 3 minutes after the electron treatment. That means we have fulfilled our requirements, and in addition, we reduce the dose. That means we only need now 5 kilograms. And as you can see, there are much smaller equipment. Now we can use a low energy e-beam facility, and this is already done by the company Bühler from Europe. And this facility is used for the disinfection of foodstuff, and can be also used for the charging of the plastic waste. So now we did the cost-benefit analysis, and we found, the net product value was increased nearly by double, and the payback period was reduced to 3 years. And the total production cost of our process is in the order of $1,000 per ton. And this sounds good. So I hope that I have shown you that using low energy e-beam treatment is one option for the sorting of mixed plastic waste, and I look forward to your questions. And and to a collaboration in the future. At the end, I would like to thank the EIA for the invitation and covering the cost for travel and accommodation. I would also like for the funding by the European Union, and my colleagues I would like to thank for the good collaboration. Many thanks.
Thank you very much, Uwe. As you can see, this is a different application, no? The radiation technology. There are no one generic application. You can tailor the technology for the purpose and the interest of what your country is interested in develop. So, or the private company is interested in develop. So this is quite diverse, and is the unique and the beauty of this technology. You can control the process for the application that you are interested in. Then is the challenge how to make it more efficient. Now we are going to move to a next speaker, and the topic now is how we also through this initiative identify what are the opportunity on developing tools that can support country in develop their technology. And with that, we will introduce Mr. Enrico Mazzoli. He is economist. Allow me to. And is a research associate at Sapienza University and an adjunct professor at Tor Vergata University. Has extensive experience designing, managing, and evaluating major United Nations programs across different regions, and his work integrates applied environmental economics with rigorous policy evaluation to inform sustainable development practices. And now he is here because he has contributed in developing tools. The floor is all yours, Enrico. Yes, please.
Thank you very much. Good morning, esteemed guests, colleagues, friends. I'm going to talk a little bit about economics and circularity. I think you've seen many good examples on how different technologies can be applied to produce new products and reach the market. But I think it's fair to say that this is a very challenging period in terms of recycling. Recycling per se is not the most profitable economic activity. In general, the competition between virgin and recycling pellets favors a lot the virgin pellets because, as you know, virgin pellets are created and generated from oil production, the oil use, and whenever that sector is subsidized or whenever the price of oil goes down, producing plastic from recycled pellets becomes more expensive. And these are the latest news. As you can see, there is a big disadvantage on recycling versus producing new pellets from scratch. But this is also visible here. Recycling itself is not bad at all when it comes to the methods. Recycling through mechanical procedure, it tends to be more cost-effective than recycling through chemical procedure. I think we saw very good examples also of the chemical potential, chemical recycling potential for producing fuel. But when it comes to checking, the checks and balances of things and the budgets, still, this is at least for some of the polymers, the advantage on virgin material is still ahead of that of recycling. Maybe glass is slightly different. Recycling glass is still more cost-effective than producing new glass. Because, of course, you need to account then for all the hidden costs of extraction of raw material, preparation of that material, washing, pre-treatment. And when it comes to recycling, at least for the pre-treatment and the sorting and the cleaning, that's a big chunk of the costs that you have to take on the budget. Same story. Here you see the difference between recycling pellets price and virgin material. And then the dotted line is the zero line. So whenever that's above, it means it's more expensive. And of course, recycling pellets also differs on the usage, whether there is an advantage or not, depends on the usage of that pellets. On the blue line on top, you see the pellets used for food contact. So when it comes to that, there are other barriers that comes into place. Regulation, the fact that some of these products may not be used for all purposes. So there is an unfair competition when it comes to recycling, once again. But this is where we get the catch. The catch is that when you go beyond the market and you start accounting for the externalities, things may change slightly. So here you see how much should we spend in order to offset the larger environmental, social, and economic damage that we generate by producing new waste. This is in the range of 300 to 460 billions, and these are the latest estimates. I think it's from UNEP study and then revised by others. So when we start accounting for all the elements and we start looking into the different aspects of costs, the picture slightly changes. And so this is just a quick background of why we then decided to start working on a tool for the assessment of these technologies to check whether they are profitable. I think this is something I've said. I've been working with this team since 2020, and I think it has been a very nice journey so far. I've been working with excellent technical experts, bright minds, but I think there is an issue when it comes to developing technologies, especially for scientists. You like your technologies too much. You like to be in a laboratory, you like to work on it, but you don't look far beyond your laboratory. So it's very good to have technical experts looking at how to improve the procedures and the machinery and all the likes, but then you need to understand how to reach market. And this is some of the most common questions I get from some of the technical experts around the world. I have this very nice product, I've been producing this with this and that technology. What can I do with it? Probably some of these questions should be asked in the first place to see whether there is potential for a product to be developed. Of course, there has to be technically sound, but it has to be also marketable. And so the reason for the tool was really to show the numbers to managers, to those that don't speak the technical language like you do. But then also to verify on an evidence base whether there are benefits or costs. And then, of course, capturing externalities. So we developed around between 2020 and 2022 this tool that was launched in 2022, which is the eBeam tool, standing for Excel-based Economic Assessment Modeling Tool. We weren't that creative at the time, so we may change this title sooner or later, especially because of the updates. But this is a very quick and easy tool that we created as a result of some of the training sessions that we're delivering to some of the member states and some of the technical experts. I remember Jordan Madrid was one of the first to see and use this tool, and then I think he actively used it for seeking financing for the technology you just showed. And so through the tool you can check your costs, see whether there are revenues, compare the performances, and then generate cost-benefit analysis reports. As said, we as a team deliver training and workshops, and this is a perfect setting for both providing the tool but also gathering the feedback and understanding what else can be done. Because we like to fine-tune the tools, but also we like to expand the products. And in fact, as a result of it, I don't know what happened to the slides. These boxes are a bit all over the places, and the icons as well. But we had the new indicators to capture also part of the environmental externalities that are generated through the process and compared to the business as usual scenario. So we added some of the life cycle impact assessment indicators. We added some of the footprint indicators for carbon intensity, for example, and other efficiency indicators related to the process. And so this is the addendum that we just did to a new tool that will be soon published on the website, and it contains new features, there are new graphs, there is a dashboard. It's quite an easy tool. You have to work on one sheet, and then on the other sheet you get all the results and all the budget comes along, so you don't really have to understand too much of economics to run it. But of course then you have all the glossary of the terms, so you also understand what you're doing. Where to find it is probably the second most common question I get it, and whether it's free to have an open access. It is. You just need to register on the Nucleus portal. You can scan the QR code, or you can just Google Nucleus portal IAEA, and then you will get to this page. You register, and then you get the tool from these other pages. Again, the QR attached, and I think you will get the presentation anyway. And here you have a couple of tools. One is the eBeam tool, which I just presented, and then to return the favor to Uwe, who just mentioned the eBeam tool, he also developed a very nice tool, which is the eBat, to understand the maturity level of your technology. So these two tools combined can help you understand at which level of maturity are you in the process of developing a new technology, bringing it up to scale for industrial level use, and then whether it's economically or not. And then probably the new tool will be also included in this page. We like to keep ourselves busy, so we keep continuing developing this, fine-tuning this. We are developing new tools also for wastewater treatment, and actually in 2 weeks' time, we'll be delivering a first version of it in Uruguay with another workshop. And then we're also expanding, as also mentioned and hinted by Hoover, we expanded the use of these for life cycle assessment in a more comprehensive way. And that's it. Thank you so much. I would like to say, thank you. I'm very grateful to the NUTEC team in general. We've been working a lot on this, but mostly to the users of this tool, because gathering the feedback, again, helps us a lot to understand what else can be done and how can we really bring this technology to a much larger scale of use. Thank you.
Thank you very much, Enrico. So I would say that you could see a little bit of what this NUTEC Plastic Initiative is about in the upcycling components, the different applications that are potentially implemented. We need to figure out now how to adapt better the technology to this kind of application, and this application to the technology to make it more efficient also now. This is our challenge, what is coming. But it's evolving. It's evolving according to the finding, or the team that has been working through this long journey. And these tools are not standalone. They are developed based on the demand of the knowledge that is, or the gaps that are still there. So we identify, as Enrico has said, all the team that has been working at the research lab, at the lab scale, they develop very good results, but then when they have to go out, to scale up the technology, is where they find some challenge. That's why we developed this tool and economical feasibility studies. And also then the other was the TRL approach, the EVAN tool, that was to guide the teams in the roadmap that they need to continue progressing step by step to go from the concept idea to the lab scale testing, the more environmental and more realistic testing, to the pilot, and potentially the deployment of this technology at the commercial scale. So that was another tool that we identified that was needed, especially to facilitate the way. And now, with this circular economy approach, we consider that it's so important to have a tool that can assess how this technology really create an impact in the circular economy. So that's why it's very, very dynamic, the kind of activity that we can develop. And we are here as IEA to try to support what are the needs from the member state. But with that, I would like to open now the floor for all the questions that you considering need for your interest, for your country. And we have here the expert and the experience through this long journey. Please, when you are asking, please introduce yourself and point out who will be the expert that you would like to answer.
Come on, ladies and gentlemen, do you have any questions? Feel free to ask. Ladies and gentlemen, there's no wrong questions here. There, on that side. Please, the roving mic.
Thank you. My question actually is for the panelists that...
Sorry, can you introduce yourself first?
Sorry, my name is Johan Yang. I'm from Viro, from Indonesia. And my question is actually regarding the green diesel. In that process, are you able to use any kind of mixed plastic material, even, let's say, flexible packaging within the process? Or is it something that you have to sort specifically? Thank you.
All right, thank you for that question. First of all, what we are currently using right now for our feedstock is three types of plastic: PE, PP, and PS. All of these three types of plastic you can yield Euro 5 graded diesel fuel. But how about other types of plastic? I just found out yesterday, PET from Prof. Uwe, he said that the PET can actually yield more carbon black. It cannot yield a lot of diesel fuel, but it can yield carbon black. Carbon black also have a market in it. But for PVC, it's quite contaminated. It has chlorine in it, so it will actually disrupt our technology. For what you call PU and PC, polyurethane and polycarbonate, both of these we have tried. It doesn't produce diesel fuel, plus it produces harmful gases. And that's why in Malaysia, we have scavengers in the landfill where we put a value to the plastic that we want. And we pay to them, and they will collect and segregate them and give it to us.
Any other question, please?
My name is Wu from China. I have one question to Malaysia team. You mentioned the pyrolysis of recycled polyolefin with radiation plus catalyst. So what is the function of catalyst? I mean, if you don't put catalyst, so what is any difference in your final product, for example, the yield of diesel? And another question is, what is the dosage of catalyst you used?
All right, thank you for that question. First of all, what is the function of our catalyst? So the function of our catalyst is that we reduce the temperature. If you are going for pyrolysis, pyrolysis uses high temperatures around 800 to 1000 degrees. With our catalyst, we reduce the temperature of breaking the hydrocarbon chain to about 250 up till 350 degrees Celsius. That's the function of catalyst. And how much dosage of the catalyst are being used for our technology is that for every 5,000 liters of production, I think just around 5 kg of catalyst. It is our own patented catalyst. It's a metal-based catalyst.
Sorry, clearly, what is the percentage of catalyst that you use?
The percentage of catalyst that we use, maybe around 2% out of the process. So for every 5,000 liters, we need around 5 kg of catalyst. The catalyst is our own catalyst. It is in-house catalyst, a metal-based catalyst. So for our what you call recurring income, so means if that you buy the technology from us around 8 million US, our recurring income is from supplying the catalyst. Without the catalyst, you can also produce the fuel, but with a high temperature, and it will eventually spike up your operation costs. And your ROI will be a lot more than 5 years, I think. For now, it is 5 years, but if you are able to get plastic credit, you are able to sell the carbon black at 40 ringgit per kg, your ROI will be around 1+ years.
I believe we have, yeah, here.
Hi, hello, good morning. My name is Jade Catherine Castro. I'm here representing Sentinel Upcycling Technologies from the Philippines. I have a question for Mr. Matsoli. So we have existing plastics recycling scheme and it's in operation at the factory level, and we're here because we're interested in seeing what possible additional technology, nuclear technology, we may be able to adapt into our recycling processes. So I just wanted to ask if your assessment tool is limited to the inclusion of the nuclear technology, or it can be used already for existing recycling processes.
I'm sorry. Thanks a lot for the question, which I didn't get clearly. Can you repeat that?
So I wanted to ask if your tool is ready to assess existing plastic recycling processes so that we can compare it with or without the addition of nuclear technology.
Correct. So thanks a lot for not asking where the tool is, which is a really good thing. Yes, you can actually, the tool is framed in a way where you have always a comparison of the business as usual scenario, or a without project scenario, as we call it, and the with project scenario. So how moving into or transitioning into the use of new technology, adding capital costs, can benefit either your existing process or comparing two very independent processes that you want to establish. So you can either compare a new investment to an alternative new investment, or an old investment to an upgraded investment. That's a kind of logical frame that is used in the tool. So yes, I would say yes.
Thank you.
Good morning, dear excellencies, dear delegates, to my fellow participants and to everyone present here today. I am Ken Dexter T. Molina, a youth participant and a grade 12 student from San Francisco High School, and I'd like to ask a question with regards to the Prex plastic prototype from the Philippines representative, Dr. Madrid, and Engineer Lemon. Does the construction method of the prototype require specialized tools, or is it compatible with community-level building processes or practices?
Okay, thank you for the question. Interestingly, during the construction of the prototype house, because that's actually one of the goals of why we would like to push through with the construction of the prototype house, we would like to see, as per our, from the advice of our IAEA experts, that aside from proving the technical feasibility in the laboratory and in the upscale, which we have proven and shown in the presentation, how are we going to, well, construct houses from these materials? That is something which is out of, like, not in our field of specialization. And so, when we discussed this with the architects, with the engineers from our partners from the Polytechnic University of the Philippines, we described the material to them. We gave them the specifications. And then they provided us like proposals. How are we going to connect this items, these materials together to build, for example, the walls, the floors. So those are proposals, and we adapted their proposals. And so we were able to construct the structure of the house. Now the next thing is, how do we finish the house? How do we, like for aesthetic, how do we put the paint? Are conventional paints going to stick or going to be applicable to our new materials? And maybe you will see later that the answer is yes. Fortunately, the existing paints, they can be used for our Prex plastics material. Those, for the paints, I'm very thankful from the input from our private company counterpart, Engineer Lemon, because they've shown us previously that I think acrylic paints are applicable for these types of materials. But since we added something, we changed a portion of the methodology of producing these tiles, these boards, then we need to show that the methods that they've developed could be adopted for the Prex materials, and it worked. But it worked now because maybe this could be considered as day zero, but we need to evaluate them. Like, will this last for how many years? We hope years, but I think that's the whole purpose of this experiment, and I'm excited to see the results. Thank you.
To add on that, probably right now we are creating the scripture on how to develop the Prex house, and at the same time, this could be the start of an endless possibility, because right now we develop something that can be useful for not in the Philippines and for the whole world, because we are thinking of including it to the construction building materials, and at the same time to make sure that it will be prolonged for a very long time. Thank you.
Good morning, everyone, and thank you very much for a very interesting discussion from our panel members. My question is actually to Dr. Mazzoli. UNIDO obviously works on circular economy a lot, and as I mentioned yesterday, we are tackling different value chain and proposing, of course, circular economy approaches. UNIDO has developed a circular economy framework, but I think it's missing the economics. And my question is, this bridging economics and circularity, I think, cuts across this different supply chain even. So we're really very interested to see how the application of your economic tool can actually bridge, electronics, for example. So it's a very interesting exercise, and I think the narrative on economics will come very handy to support, for example, policy-making decisions for our countries that we assist. And therefore, I think there is a conversation that might be necessary, and really, really very happy to see all the efforts being done on plastics, especially in this forum. Thank you very much. It's not a question, but more really a request from our part.
Thank you so much. I think we very welcome the request, and I think also it's fair to say that UNIDO has a long history also in working on the economic evaluation of things. I know, and I've been trained on COMFAR, which was one of the software that we also considered when we started this, but we noticed that the suitability of that, or the adaptability of that software within the context of plastic recycling and within the context of e-beam technology was not immediate for the users as well. So we decided to go into a way where we could create something which was very easy to use, quick, and didn't need too much of the training. But absolutely, I think we will be extremely happy to collaborate. It was also in the spirit of this whole initiative to bring different partners here to scope for synergies and partnerships. So absolutely, we'll keep in touch.
And if you allow me to add on that, actually, with UNIDO, we already have some conversation to expand our collaboration, especially on this circular economy approach, because we know that you have the experience, you have the connection, the networking, this framework, and we don't want to duplicate effort. We want to join effort and make it more synergy in order to approach, and also talking in the same language. You are having the connection with the industry, and IEA is not directly sometimes connecting, but now we are having this networking as well. So, but the idea is to try to join effort, working together, and talking in the same language. That the idea is to try to contribute what you are already doing, and vice versa. So, absolutely agree, and thank you for pointing this. Actually, next year we are already planning some training on circular economy. So there are already ongoing plans there. So thank you very much also, Enrico, on that. Any further question for the audience? If not, I would like to ask a question to you, Franco, because I know that you have developed this, you have together with the CONEA, have developed this technology to apply for specifically for a sleeper, railroad sleeper. But I know that you have this lesson in this application, and maybe you are thinking already on apply this technology for another application. Do you have this in mind now?
Nope.
Yes.
Yes, thank you for the question. All the structural product development can be applied in other industries. Right now, we are working with a partnership in Argentina to develop a plastic frame. It's like a housing builders, but making in our factory, and then we sell the house already done to our clients. And different industries start to looking for different structural products to replace wood, to replace concrete, to replace another materials. So our team starts every day trying to develop new products and new technology to apply to these industries.
Thank you very much, and it's very exciting as well. And if there is no another question, I would like to ask also to Uwe, especially on this electrostatic sorting that I am considering that is very, very good tool, especially for improving the quality, of the raw material, especially for fabric or textile. So how is this technology competing with another ones? Is there something that cannot be achieved by other technology and you are having this uniqueness technology, or is something that you consider that it has an advantage for the future?
Do you mean the low energy e-beam treatment?
And the electrosorting, yes, application.
The low energy e-beam treatment can be used for the sorting, but also for the compatibilization. When we are looking for the preparation of high performance polymers, then in most cases the companies are using the reactive extrusion. One chemical agent is maleic anhydride crafted polymer, and this is used by only 2%. When we are using low energy e-beam treatment for the compatibilization, then we only have to modify 2% of the volume of our plastic waste. And this means we can use the low energy e-beam. And by using this technology, we can reduce the cost. And as I have learned yesterday, in Europe, you have to pay roughly 400,000 euro, but in China, only $120,000. That means this is a cheap technology, and if you have some requests, then please contact us, and we can help you and give some comments how you can use it.
Thank you very much. And now with that, I guess that we have come to an end of our panels, and I would like to thank all the panelists. Thank you very much for your exciting contribution. I guess that it was a very concrete example of what can be done, and they have made an amazing work in developing this together and collaborate together among the research team plus the partner, and also it was not just a partnership among two, it was in some cases even with others, companies that were involved in this collaboration. And I really like some of the comment that has been made during your presentation. Have plastic as a resource. That was coming from Jordan also. That is very amazing. Now we are considering that the plastic is not, it is an issue, but now we are finding that this war, plastic, is becoming an opportunity. It's a resources, and potentially a renewable resources if we are considering what, for example, the Malaysia team is doing. They are applying a technology that can make now fuel again. So this is exactly the perfect way to go back to the starting point and apply this fuel now for another purposes. So I also like pretty much, when it has been mentioned that this technology give the possibility, but also the commitment, I will add, of making this new material recyclable again. So at the end of the life of this material that they are producing, this can be recyclable. We are not generating a problem for the future. So that is something that has to be in mind, when they are developing this new material. They have to be also responsible that the material will be recyclable as many times as needed to keep the plastic in the loop. And this is what we are meaning also. We are talking about circular economy, create value, but also keep the plastic in the loop, in this loop, in the closed loop, avoiding that the plastic can reach the ocean or others, environments. And also, I was considering that if we are creating value from this plastic waste, the hierarchy, of this industry that you are creating now has completely different level. It's not a low industry. They are creating value, but also the job description, the job that are being created can increase the hierarchy, of the labors. So that's amazing as well. And most of you have started for a very heterogeneous material, But additionally to that, they could create a very reproducible result at the end of the process. So that is another very good finding, because coming from such heterogeneous plastic waste and achieving a material which results are showing that are reproducible, that's amazing. That's amazing. And that was one of the concerns when we are talking about plastic recycling, So, and also improving the sorting of very similar polyolefin, through this electrostatic sorting material with compact equipment, that's another very good advantage on creating good and better quality feedstock for others' application. So I believe that the application has a huge potential. We are continue working on developing strategy, tools, adapting, testing, creating knowledge, that the researchers team, but also the industry can decide what is the best for the application that you are interested in achieve. And you are most welcome to approach our teams as IEA and also identify what are the demands that you are having, and we will try to adapt to, the interest that you are having. But, you have listened to the expert and the finding from their approach and their, project, how they have implemented, and the concrete result that they have achieved. So with that, I thank all of you for listeners, for being part of this panel, and the expert who made an amazing job. Congratulations all.
Thank you so much to our moderator, Ms. Selina Hora, as well as our distinguished speakers, Mr. Franco Frola, Mr. Ting Teo Ming, Mr. Mohammad Aidan Yusuf, Mr. Jordan Madrid, Mr. Winchester Lemon, Mr. Uwe Goss, and Mr. Enrico Mazzoli. Ladies and gentlemen, let us give them a big hand, please. And that concludes our session number 3. But ladies and gentlemen, before we proceed to our next segment, we'll be having a short coffee break. A reminder, our refreshments will be available at the foyer area, and we would just like to reiterate that our exhibitors will also be available, so please feel free to visit, and we'll resume at exactly 11 a.m. Please enjoy your short break, ladies and gentlemen. Ladies and gentlemen, in a few minutes, we are going to resume our program. Once again, ladies and gentlemen, in a few minutes, we are going to resume our program. Thank you. May we request everyone to please settle down, and in 1 minute, we are going to resume our program. Once again, we are requesting everyone to please settle down as we are about to resume our program. Thank you. Welcome back, ladies and gentlemen. And at this point, we'll be proceeding to our session number 4, highlighting global capacity building successes, harmonized monitoring protocols, and new tools supporting member states in marine microplastics research. To lead this discussion, we invite our moderator, section head for Latin America and the Caribbean, and at the IAEA Department of Technical Cooperation. Please welcome Mr. Saul Perez Piwan.
Good morning, ladies and gentlemen. Welcome to session 4 as announced. I'd like to start by saying that we are all aware that microplastics and nanoplastics have been detected in human blood, in placenta, in lungs, and emerging evidence coming from tests conducted in whole animal, or at the cell level, shows that these particles can cause inflammation, oxidative stress, and disturbances in the immune system. So we are also aware that a long way relies ahead of us in terms of research, development, experiments, to understand exactly what the impact of micro and nanoplastics have in human health. But in this multi-step approach, it's evident that it's needed to characterize the hazard, it's needed to assess the pathways of human exposure, characterize the risk, and provide the mitigation measures and policies to protect human health. Today, our panelists will dive into challenging questions that are driving the IEA contribution to the global community through the NUTEC Plastic Initiative. Questions that we have all in mind, like, for example, recognizing that this is a regional and global issue. How are we collaborating at national, regional, and global level to provide science, evidence, information for decision makers? Or one of the most popular question among the decision makers. Our decision makers need to see the photo, but also watch the movie of microplastics. Then how microplastics accumulate over time in the different environmental compartments. Can we do that? And of course, having such set of data, we ask ourselves how can this data be widely shared with decision makers and the international community. Those are part of the questions that are driving the IEA assistance through the NUTEC Plastic Initiative. Allow me to introduce the incredible experts and scientists that will join this panel. All women, by the way. Starting with Ms. Ana Carolina. Ana Carolina, researcher, Institute of Marine Science and Limnology, National Autonomous University of Mexico. She's a senior researcher, focuses on isotopic geochemistry and geochronology, applying nuclear techniques to reconstruct trends in global change. Her work, endorsed by 190 peer-reviewed publications, my dears, and 20 international projects, includes evaluating the impacts of climate change and pollution on marine and continental ecosystem. Welcome, Carolina. Ms. Kishni Pillai, marine scientist, Department of Forestry, Fisheries and Environment, South Africa. Kishni is a marine scientist based in Cape Town, South Africa, leading a government monitoring program encompassing 13 projects that focuses on producing essential ocean variables, and her work expands the integration of in situ imaging and satellite data for zooplankton monitoring and alongside research on marine plastic. Welcome, Kishni. Ms. Irene Barra Rodriguez, Associate Professor, Marine Science Institute. We could not leave behind the Philippines experience in this panel. Irene holds a PhD in chemistry from the Karl Franzens Universität Graz in Austria, and is currently a professor at the Marine Science Institute and principal investigator of the Inorganic Biogeochemistry and Biotechnology Research Laboratory at the same institute. Their research group addresses a gap in Philippines by expanding the infrastructure and technical know-how in studies devoted to trace metals in environmental and biological systems. Thank you. And last but not least, well, it's by courtesy, IAA is the last one. Huh? Shiddan Bahadir is Unit Head, Software Solutions, Department of Management, IAA. Shiddan is an experienced professional with specialized experience in digital transformation, management, and IT consulting services. With a strong track record of driving innovation and operational improvement, Shiddan helps organizations like IAA leverage technology to achieve strategic results. Welcome, Shiddan. Then I hope you all are ready for the stimulating discussion with these incredible panelists. And if you allow me, I will start now provoking a little bit through questions these ladies. Let's start with Carolina. Carolina, your institution is part of the research network of marine and coastal stressors in Latin America and the Caribbean, known as Remarco. Could you share how Remarco has helped address one of a specific challenge of the NUTEC Plastic Initiative, namely the harmonization of protocols? And in turn, how has NUTEC Plastic, in the other direction, has strengthened the work of your regional network? I'd like to see where the control is. Do I have the control with me? Let's see. Well, you can take this, but no.
Okay, this is working, yeah.
Now it's mute. No, this is not working.
Not working, okay. I think the controller of the is there, or no, it's just a phone. for the first slides. Well, I wanted to show you a presentation about what is Remarco. I would like to introduce first our network. Remarco is a non-profit association of collaborative research among 18 countries in the region of Latin America and the Caribbean that has been created over the years. We started working together in 2007 with the support of technical cooperation from IAEA. So thanks to these technical cooperation projects, regional technical cooperation projects. The slide was good. Who's controlling it? Okay.
I prefer to have the control.
Yes.
If you don't mind.
Yeah, I prefer to. Please, come on.
Here we go.
Thank you. Okay, so this Remarco is the research network of marine coastal stressors in Latin America and the Caribbean. I was telling you that we have developed this network as a result of the cooperation, collaborative work with these 18 countries in Latin America and the Caribbean. You can see them in the map, painted in green. And we work together, aside the arm of together, scientists and communicators with the idea to improve the regional capacities to produce scientific data, but to transform this scientific data into effective communication of the scientific information for decision makers and for the general communities, with the idea to develop public policies to tackle key challenges that we are all facing in the marine environment in the region. We have imposed, we have prioritized the South-South collaboration since the very beginning, because we wanted to have information discussed and produced, published in our own languages, and to have these harmonized protocols and to produce joint databases, to have projects together, to produce scientific publications, peer-reviewed scientific publications, to develop regional observatories and friendships and much more among all the collaborators. Can we go to the next one? So I was telling you that Remarco was born through this collaborative project supported by IAEA along the years, but in reality, the idea was to add different components to the network, that we developing the capacity in our country to tackle on the very beginning the lack of monitoring that we had for trace metals and organic compounds in 2007. So we developed the capacity for lead-210 dating to provide a historical reconstruction of pollution by trace metals and organic components. Then we have the component of harmful algae blooms, ocean acidification, and we arrived in 2018 to ocean acidification. Now, and also in this year, we have the component of communication, ocean acidification, and currently we are developing, besides microplastic contamination, blue carbon and eutrophication. Next one, please. So the transversal component that lead us to give this scientific information to the stakeholders is the communicator team. And all together we are working in standardized methods for scientific work, but also to produce this translation into common language, adapted to the region with all the limitations that we might have in the region, but it is still there in our own languages. And we are working hard to data reporting, to have that integration into databases, scientific publication, project reports, and scientific outreach. So one of the key work that we have developed in the past, starting in 2018 with the microplastic, was developed the guidelines for determination of the abundance of microplastics, either in the surface water and in the sand beaches. So when our institutionalization, when we have finally defined Remarco as this network supported by IAEA in 2019, we had already a series of protocols that were already established for all the other components also. But when the NUTEC plastic was launched by IAEA, we were invited to step forward and try to bring our experience from several years behind on how to work together, how to develop these analytical methods that have been introduced into guidelines, and to help other regions to develop the same capacities and the same collaborative work that we have already done. This, I think, has been very important because we had already trained and skilled scientists, laboratories that were able to use specialized methodologies for characterization of microplastics. And we had also the experience in several of our laboratories in lead to 10 dating to do the historical reconstruction of microplastic pollution. And we had also the experience on the collaborative work to produce data, to share the data, and to be able to host this data in an application online that will also allow the analysis as a collaborative work altogether. So that was, I think, an important contribution from Remarco to develop the collaborative work in other regions through NUTEC. But also our region is getting a lot of support from NUTEC Plastic now to improve our methodology for the characterization of microplastic, which is a really, really big challenge because the analysis of the particles, as we have done it until now, one by one, is a very handcraft activity that takes a lot of time. And we hope that very soon we will improve that capacity, making it more efficiencies so we can analyze much more samples in lesser time and to advance generating knowledge in the region. Thank you.
Thank you, Carolina, for your insights now about the connection.
Thank you.
Between the regional collaboration and NUTEC Plastics and vice versa. And then let's connect now NUTEC Plastic Initiative also with the global efforts, not only the regional endeavors. As we all know, in 2021, UN launched the Decade of Ocean Science for Sustainable Development. Today, we are honored to have Ms. Kisni Pillai, one key contributor to the decade's actions in Africa and to the monitoring of essential ocean variables under the Global Ocean Observing System. Kishni, how do you see the NUTEC Plastic Initiative fitting into the global landscape of collaboration for monitoring of the marine environment?
Thank you, Saul, for the question. And I think to understand how does NUTEC fit into the global sphere and into the global framework, we first have to understand what that global framework is. And not so long ago, or maybe a while ago now, a group of people sat in a room probably similar to this and made a decision that as the human population and member states of United Nations, we were going to say that these are the goals that we all subscribe to for the next decade, for the next 10 years. And for the first time, one of those goals, or two of those goals, involved the ocean and it involved the environment. And it elevated the oceans and the environment to the same level as ending poverty, to ending gender inequality, which is huge. And these are noble things, but almost seemingly unattainable. But for us in science, we need something that is tangible. We need something that's operational. And that is where the Ocean Decade came in. So the Ocean Decade took that goal. It took goal 14 that dealt with the oceans and said, okay, over the next 10 years, this is what we're going to do. We're going to have these indicators, and this is what it's going to mean. And one of those indicators was about plastics. There was a recognition that plastics was a huge problem in the environment, but we don't know how big of a problem. And that is when NUTEC's plastics would come in. What they're calling for is monitoring of the plastics. But over time, we didn't have a mechanism, we didn't have a method on how the globe, not just one country, but all countries, are going to do this. How are we going to get comparable data? So one of the systems where we use to get comparable global data is the Global Ocean Observing System that you mentioned. And there they've described these things called essential ocean variables. So it's things like temperature, carbon, all of these things. And we have methods, prescribed methods, and we all know as scientists how we're going to collect these things. And this does not exist for plastics. And that's where NUTEC comes in. So NUTEC doesn't just develop a method, but it allows for that collaboration. It allows for people on a global scale to say, these are the methods that are in existence, how shall we harmonize that and come together? And so it levels the playing field. So exactly what Carolina said for the Latin America region, we do in the African region, and Irene does in the Asian region, which means we're all giving comparable data. So that allows us to actually understand something meaningfully, because we're not just giving data, which there's been a data call since yesterday, but we're giving data that can be transmitted into information. And one of the things we're doing for the Ocean Decade is within the African region, we have 16 projects, which is 16 nations who have national projects. And these national projects all come together under an Ocean Decade project, which is looking for a common method, and then that's a regional project, and then it will all fit into a global project under NUTEC. So on a national level, if you are investing effort, and for scientists, our effort is our time, our infrastructure, our consumables, whatever that effort may be to us. But as a government, your effort is money. And if you're investing that, it is not wasted, because under this, the national priority and your regional priority and your international priority are all seamlessly talking to each other. So by on the ground, scientific information is now finding its avenue into the international space without trying too hard, which is quite a feat for right now. And I think that's important because we keep saying that the global, plastics is a global problem, but it requires this. It requires a shared solution.
Thank you, Kisnit, for explaining the insertion now of this look for the synergies now between the different level of cooperation. Then, dear friends and colleagues, one of the cornerstones of for identifying microplastics is technology transfer. And I would like to address Irene now. Irene, could you update us on the progress in establishing NUTEC marine labs in the Asian Pacific region? And what do you think are the main challenges for the technology transfer within NUTEC technology? You don't need to mention all the challenges, just a few, please.
Thank you, Saul. So following on the point of questioning earlier, that the plastics problem is a global problem, but with a regional solution, and sometimes on a national scale. I'm showing here the Asia-Pacific region, and there are very unique challenges, but very unique opportunities as well, being offered by the region in terms of microplastics monitoring. First and foremost will be the disparity in the socio-economic status of the countries in the Asia-Pacific region. We have to consider that because that will have an impact on the technology transfer. So access on all the reagents, the chemicals that are required for the conduct of monitoring, as well as the implementation of harmonized protocols for sampling. All of this will be influenced by that. And that is really what is commendable about the NUTEC initiative of the IAEA, is because the goal is for all of the participating countries in the Asia-Pacific region to be provided with the sampling kit as well as the analysis kit. But if you now factor in the sheer distance between participating countries, the ones that are marked in the figure that I'm showing here are the microplastics sampling stations selected by the participating countries in the Asia-Pacific region. And if you will observe, it highlights that there are areas where we don't have any sampling station. And that is, again, one of the challenges, because even if a country has established microplastics monitoring laboratory, one country will require that that effort or that laboratory be multiplied several times so that it can have the capability to monitor or to do sampling even on an annual scale on the coasts or the surface waters that are covered by its jurisdiction. One other thing that's notable about the Asia-Pacific region is the number of, the population inhabiting the area. So we're talking about an area that has, where a lot of countries are topping in terms of population density. And we know that with increased population, there's also increased utilization of plastics. And that translates to microplastics being mismanaged, not intentional, but that's just the reality on the ground. And considering now where the region is, it's influenced by oceanographic currents, it's influenced by the monsoon, and when you have the southwest monsoon or the southwest monsoon or the northeast monsoon prevailing in different seasons, then that will influence where the microplastics are coming in. And depending on the location of the country in Asia Pacific, it can be a receiver of microplastics or it can be a contributor of microplastics circulating all over the oceans. So with that point, it is very important to include the small island developing states, because some of these states may be receiving the microplastics being produced or being released someplace else, but we really don't have an idea on the level of microplastics in these regions. So it's very important that the technology transfer be, that the seeds be included in this technology transfer, because that will improve the data, that will improve the knowledge of where the microplastics are being released and where the sources and the sinks, basically. And what's also unique about the Asia-Pacific region, that population being in the area, that translates to a potential for people to be taught the basics of microplastic sampling and the analysis. So that's a human potential that can be capitalized on, but there is a need to increase the number of monitoring laboratories, and hopefully that increases or enhances our capability to contribute to the global data on the sources and sinks of microplastics. Thank you.
Thank you, Irene. We do count on Asian Pacific to expand our network of labs now under the NUTEC initiative. Let's continue moving the conversation about technology, this time information technology. Then, given that the lack of data on microplastics is recognized by everyone and our sister organizations, etc., how will the NUTEC Plastic Initiative contribute to create a platform for data collection and sharing?
Thank you for the question, Sol. As indicated by the previous panelists, it is indeed very important to have reliable and scalable as well as comparative data on a national and global level to be able to have a proper insight in terms of where we are with microplastics issue globally so that we can address it. But in order to have that information and the key insight that the scientists have been collecting all around the world, we need to have a global common platform, an IT solution and a system that will facilitate the collection, monitoring, assessment, and reporting of the whole sampling data that our fellow scientists have been collecting on the world to properly report it. Unless we transform the data into a meaningful information, share and collaborate, and knowledge transfer with our counterparts, it will be very difficult to assess where we are and how we can address it. For that purpose, we are pleased to let you know that we have developed a global platform for the NUTEC Plastic Global Marine Monitoring. Together with our member states in collaboration with our counterparts within the IEA, we have been working on a project to develop this global platform that will serve as a common and main platform to the whole contributors of the IEA member states to collect the sampling data, analyze it, monitor it, and report it in a unified fashion. What is also critical to mention here is to highlight that the system, the platform, should facilitate following the same standards, templates, within a unified and harmonized way. The data sets, as what we call metadata that we have established in the systems, should be unified in a way that we are all collectively talking with the same vocabulary, same terms of references in the system, so that we can share it, we can compare it on a national and global level. So this global, if we can go back to the previous slide, please. The previous one, yeah. A few things I would like to mention that this global platform will serve as a strategic asset that we offer to the whole participating member states to facilitate and enable them to enter their input in a secure and accessible way. It will be made available to all the participating counterparts, and it will not be limited to a certain nation or on a regional level. So it will be open and accessible to all in a secure way so that the data can be entered and processed and analyzed and report as an end-to-end in an automated fashion with very minimal data manipulation. It will hopefully improve the visibility and transparency across the world to sharing and collaborating with our member states. Next slide, please. Some of the technical components and details of this global platform is going to be leveraging some of the software vendor providers and the technologies that we partner with as IAEA. So the platform will be, as I mentioned, will be accessible by whole users, the whole participants, i.e. the nations on a national level, the selected and nominated laboratories and their respective users will be able to access to this platform using a secure portal called Nucleus. This is our single sign-on portal that we have used in our IEA infrastructure. And this is a secure portal, and this access and security will be determined by the user roles and their respective permissions. So it will be fully secure, validated, and controlled environment. Underneath the platform, there will be a secure data repository, which is what we call it as a database in technical term, which was inspired by Remarco. Actually, while we were designing this solution, we were inspired by Remarco database, and we've made very benefited from the Remarco's design as well. So the data repository will be in our custodian, as an IEA will act as a custodian of the database, which will collect all the respective information and data entered by counterparts. And we will be, as IEA, will be hosting and securely supporting this global database. Once the users enter into the system, they will be able to start populating their templates with their sampling data. For the data collection part, we have partnered with a software vendor company called Iris, which I'm going to come to that and explain a little bit more detail. This is a web-based application which is very user-friendly and easy to use and navigate around to populate the sampling data. But what I would like to mention here is that it will definitely follow the unified approach, i.e. meaning that regardless of which laboratories, which region, nation, everyone will be following the same unified protocols and the templates to start with. It will facilitate the multiple user roles. The users will be defined on the lab admin as a sampler or analyst to collect the data. So the one final piece of the technical components is the visualization and reporting, which I'll come to that. If we look at on the solution overview, how the workflow and how the facilitation of the data collection will be enabled end-to-end starts with the sampling. Of course, for the sampling, we will be following the protocols, which are harmonized protocols to collect the data, sampling data, which our scientists have been doing. Once the sampling data has been collected, this data will be entered into this international research integration system as a data collection tool, within following the standard, unified, and consistent approaches, methodologies, templates, and processes. The data collection, once the data collection is complete and entered into the system, then the respective person, whether that will be an analyst or lab admin, will be validating, checking the accuracy of the data. We have also enabled some of the automated functionalities within the system to do the automatic checks. Once the validation is complete, data is assessed and approved by the lab admin, then the data will be submitted for visibility and knowledge sharing. So there will be a definitely validation process before any data is made available online and as an open data. And the system will enable and facilitate this automatic approval process. The whole collected data will be aggregated and consolidated within a single platform, as a single database, as a single source of truth, because we need to have consistency. We should be able to have the consistent set of data, the same data sets in a consistent way. So the global data will be aggregated and consolidated, and then through some mechanism will be published as reports. I also would like to mention that in terms of sharing, collaboration, and knowledge transfer, we will be also building a link with the UN Environment Programme Global Database, which was mentioned yesterday on the previous panel, to share the national level statistical aggregated data in an automated way so that every year the submission will happen and the UNEP will have a full visibility of what has been collected by respective laboratories around the world. And we will be sharing this information following the SDG 14.1.1b indicators and the protocols. On that note, I can end it now.
Thank you, Sidan. Continuing with the technology, I'd like to come back to Carolina, as we mentioned how essential is understanding trends in microplastic abundance for guiding interventions and assessing policy effectiveness. Carolina, could you briefly explain the unique role of nuclear dating tools in supporting decision makers and provide a concrete achievement of their application to microplastic pollution, please?
Okay, thank you. Well, thank you for the question, and I would like to recall the public that maybe 1 decade ago, we were not aware of the big problem that microplastic pollution was in our oceans. So the information has started coming maybe around the 2014, and we haven't monitored that problem before. We don't have records. And the only way that we can recover that information is using precisely the geochronology, using the nuclear dating tools. So imagine that you need now know the trends, how this pollution has started, when, how does increase in the time. So the only way to recover that is to go with the records that are already accumulated in the sediments of the aquatic systems, continental and marine aquatic systems, and analyze lead-210, which is a unique natural radioisotope that we have available in our planet Earth since the formation as part of the uranium-238 chain that we have on the left of of the screen now. So lead-210 is formed as part of this uranium-238 chain, but there is a fraction of this lead-210 that is formed in the atmosphere of our planet as a result of the transformation of radium-222, this radium emanated from the soils. And this lead-210 that is formed in the atmosphere will eventually fall out to the sediments, allowing us to have a chronometer. So when we collect a sediment core and we analyze layer by layer the amount of lead-210 in these sediments, we are able to put a date, an absolute chronology in this sediment, and we are able to say when this layer of sediment was formed. Now, microplastics, as many other contaminants, are sinking, and they find their final destination, the final repository in the sediments. So if we know when these sediments were formed, we know also when these microplastics were accumulated there. And then we can reconstruct how these fluxes increases with time, and we would be able also to understand from where this microplastic might come. This is information that is very useful, but when the decision makers have such kind of data, they can produce scientific sound based information for regulations to take decision where to put the money that it will be more useful for controlling, to regulate the environmental impact of microplastic contamination, and how to produce agreements to control maybe regional problems that can be difficult to assess otherwise because we don't have information from the past. Can we see the next slide, please? In Remarco, we have already produced training on how to do this lead-to-10 dating. We have resources online published already in YouTube on how to work with sediment chronologies. And next one, please. And we have already a few examples of analysis that have been done in some of the coastal areas in Latin America and the Caribbean, where we have collected sediment cores. We have analyzed the sediment cores using gamma ray spectrometry or alpha particle spectrometry for do the lead-to-10 dating, and then separated the microplastic particles in these same layers, and we have transformed the record of the abundance of these microplastics into a chronology of a historical reconstruction of the fluxes of this microplastic through the time. So what we have here is an example, something that had been done where I live in Mazatlan, in the coastal lagoon called Esterodurías. The information is published in Science of the Total Environment. It's a very good journal. For us, it's very important in Remarco to produce information that is published in peer-reviewed journals because it allows us to challenge ourselves and deal with the peer review, our colleagues' scientific review, so we know if we are going in the good direction. And then this is one of the products we have produced, and now we know that, as Irene has already established before, the population is leading the contamination of microplastics. As long as the population has been growing with time since the past 100 years, we are seeing from the 1950s where the commercialization of plastic start being produced. So we start seeing also the contamination by the microplastic, and this increased together also with not only with the growth of the population, but also with the growth of the plastic pollution around the world. So the more people we have, the more plastic available, we have much more consumption, and unfortunately, so far, we have had a very bad management of these plastic wastes that I hope that with all the technology that we have seen discussed this morning, it will gonna be reduced very soon, and these trends are gonna be improved in the next future. Thank you.
Thank you, Carolina, for displaying this interesting technical tool available for our member states. Next, let's briefly focus on one of the critical elements of the technology transfer, which is capacity building. Irene, come back to you. Could you elaborate briefly on the capacity building programs that support the generation of this type of data?
Okay, thank you for that. The Asia-Pacific region, through the IAEA NUTEC project, RAS 1738, benefits a lot from Remarco because they came first. And we are benefiting in the sense that the harmonized protocols that has been implemented and used by several member participating countries in the Remarco program, we are adapting some of those in the RAS 1738 project. So that's a benefit because we don't have to reinvent the wheel, as they say. And following that, we are also using whatever technology has been perfected by the IAEA already. And then in terms of capacity building in the region, there are member countries that are already advanced. So Kuwait, for example, has been very gracious in hosting training programs for the RAS 7038 participating countries. And other countries are also offering to host meetings where these are very unique in a sense because when you visit a country, when you visit the laboratories, laboratories that are intended for microplastic sampling and microplastics analysis, you sort of benchmark your own country's capability, and then if you have the opportunity, you model the laboratory that you want to build in your home country to that lab where you have visited. And that's very powerful in the sense that you have that model again, and you sort of follow on the footsteps of those that have successfully implemented a program already. So in the Asia-Pacific region, we are rotating the training programs, the workshops, to enable participating countries to have these visits and also improve the networking amongst ourselves. Because as I've noted earlier, we really have to maximize whatever opportunities that are thrown our way. So again, because of the sheer amount of coastlines that we have to monitor, and also just the vastness of the oceans that separate us, we have to improve on our capability. So, for example, this is now from one of our participating countries. Mr. Shahadat Hussein took a video, and this is a still shot. We have to make adjustments based on the resources that are available to us. So this is now a screenshot of when they were deploying the manta net using a fishing vessel. We have to make those kinds of adjustments. So if a manta net is not available to you, then find someone who can produce it locally based on designs that are available and validated by scientists in the Remarco network or in the RAS 7038 network. So we are maximizing the resources that we have in our countries, but benefiting from the experiences of those that have done it before us, and contributing in sharing the experiences so that all of the countries will have that elevated level of capability in doing the work that must be done for microplastic sampling and analysis. Thank you.
Thank you, Irene. Building on your points, we reach the moment where the labs are created, staff trained, protocols harmonized, and then next question is, okay, how do we report the results? Then I'd like to go deeper into your introduction, Shibdan, by displaying how these results will be visible through the global marine platform that IEA is supporting.
Sure, certainly. So maybe you can share the slides. I would like to come to the data collection part, but what I would like to start by saying is that this tool or platform aims to provide and generate valid, accurate, comparable, and traceable data sets. For that, we should be able to following the same protocols, a unified and harmonized way. And data collection is the key. It's the first step to achieve this success and target. Here is an example of how the data collection will look like. As I mentioned, we will be leveraging some of the technologies developed by a software vendor company, as well as our own developed solution to collect all the sampling data. In terms of the sampling data collection templates, we're currently collecting the beach samples only from the sands, but the system and solution can be scaled up to accommodate the collection of sediments, biota, and water once the respective protocols are in place. So in terms of the template, as I mentioned, the data collection will be facilitated through the web application, which is quite user-friendly and easy to use, which has been uniquely developed to collect the sand sample data at this stage, but again, it will be further improved and enhanced to collect the water and sediments samples. The whole templates and the features and the processes are unified across the whole laboratories. So everyone will be following the same standards and same templates and same methodology, collect and input their sample data. Access will be limited to the nominated users as lab admins, analysts, or samplers nominated by their respective countries and nations. Next slide, please. This is just a sample of how the template will look like. So the templates will have some, as I said, it will be following the unified processes. It will have harmonized data sets, what we call metadata, in the system, so that all the institutions, the regions, users with their respective roles and permission levels will be predefined in the system, so that everything can be facilitated securely, seamlessly, and automated without with the minimum data manipulation. It will also have some pre-validation rules embedded within in terms of certain validations and checks of the data, such as input type, data range, the thresholds, so that the data errors of the sampling data can be picked up in the earlier stage of the collection before it gets reported to the UNEP, or before it gets approved to be published. So next slide, please. The data, again, continuing with the data collection templates, we will have all the required data inputs. As you can see, the data templates will be able to, at once, accommodate up to six sample data sets. All these ranges and the data that is required for the input from the laboratories have been defined as per protocols agreed. There will be a facilitation of not only an online submission, but the users or laboratories will be able to submit their data as a bulk upload using predefined set of Excel templates. As I mentioned earlier, all the data that is collected, consolidated, and aggregated in our system will be directly pushed into UNEP Global Database. So what are we going to do once the data collection is done? This is where the collaboration and knowledge sharing and information sharing is enabled. We will be using our partner, trusted Microsoft set of technologies to visualize all the data that is collected globally. But this will be the published data only, i.e. meaning that the data before it gets appeared on the dashboards or any form of reports will be validated, analyzed, and approved prior to that. We have defined some interactive set of visual tools or dashboards to see where the sample has been collected in the world by location, geographical location. And once you enter into database, you can you can also go into the detail and drill through the details of the data that is collected from the specific location. And the first set of data, it will be the beaches for the marine monitoring. This visual tool will be accessible through, again, our secure portal. The synchronization with the database will happen overnight. So once the laboratories enter and submit and publish their data, next day on this dashboards, they will be in sync. So the users from everywhere in the world will be able to see what is the aggregated and consolidated numbers in terms of polymers and all the key information. Next slide, please. This is again some of the dashboards and samples. It's not limited to this visuals. We will be also producing some narrative reports, PDF-generated reports, to put some narratives around numbers of all the data that is collected from the laboratories. As you can see on the dashboards, as I mentioned, currently there is only sun data. What you see on the screen is the actual data. This is actually collected sample data. We have recently published this system as a global solution to up to 27 member states for their validations and checks. They have tested the system for the adequacy to see if it's fit for purpose and if it has all the capabilities and features that is required to provide the necessary data collection and reporting. On the left-hand side, you can see the matrices. Sorry, on the previous slide. The matrices for the biodata, water, and sediments will come next once the protocols are in place. So we will be able to facilitate that through the system as well. And the next slide. Last but not least, we have also developed some Microsoft SharePoint, which is a central connection point where all relevant information comes together in terms of visuals, reports, events, news, documentations. This is again accessible through securely by Nucleus users who needs to be registered and created accounts using their Nucleus accounts. This is a very high-level view of the platform. It's quite easy to navigate and use, so we would really encourage you to use it. Thank you.
Thank you, Sidden, for providing details on where our global monitoring platform is at this point as an IT tool. Thank you. My last question is to you, Kishni. Drawing on your experience as a national node for the International Oceanographic Data and Information Exchange under UNESCO Intergovernmental Oceanographic Commission, what will make this platform outstanding? In other words, do you think that this is business as usual or it represents something different?
Thank you, Saul, for the question. And I think the first thing that we need to understand is what do we mean by business as usual? And in the Ocean Decade applications, if anybody has applied for a project at Ocean Decade, and most of the funding applications these days, they ask you to substantiate that this is not business as usual. It's kind of giving business as usual a negative connotation. And there's two things that we have to do in government. One is monitoring. Monitoring is business as usual. We do it every single day. We do the same thing over and over again. It is not the sexy science. It is just what needs to be done. And then there's new research that we do. And that is because of emerging issues that are coming up, because of new things that need to be done. But every emerging issue that comes up, there's an element of it that becomes business as usual, because there's an element of it that becomes monitoring. And that has to continue within government. So where we sit right now is that most plastics that are smaller than 5 centimeters, you don't have a methodology, you don't have something that we've all agreed upon. There's lots of methods, so it's not that it's new science. The issue, or the emerging issue, is that we have too many methods, and we need to harmonize those methods. And so that's where we sit with this is what we're doing. So it is something that's new, and it is something that should move to business as usual. It should move into that global ocean system where they develop, or we develop, an EOV, an essential ocean variable for plastics. We have so many countries sitting here now that have done all of this work and is producing all of this data for SDG, but SDG ends in 2030. And past 2030, you're still going to have these other systems. And one of the systems that we have is the global ocean system, the observing system. And that is not a data repository, but it's a methods repository, as is the ocean best practices. So these data repositories that we have that you said, yes, South Africa is the node for quite a few of these data repositories. They're very good, they're essential. They are where we put our data, and it is where we exchange our data as scientists and as people who are required from policy and all of that. The IAEA database will fit very neatly into that. But what we also need is to look at the method repositories. The great thing about IAEA and the unique thing about NUTEC plastics is if you take a step back and you look at it as a global monitoring network, just the science side, not the whole side, but just the monitoring side of it, you have something that's very unique. Every other variable that's monitored in the globe, it's very fragmented. You have tools here, you have this here, data here, methods here. But what you have here in NUTEC, like has been said by everybody, was that it was a method that was developed together, and Carolina showed some of the methods and the data. And like Irene said, we had training, we had capacity building, we had the kit that was given to us, so we were all using the same things. And then like we saw with the data that's was displayed, how we all can display data. The great thing about it is that while these things happened with member states, the actual method itself is open access. So non-member states can use this and then also continue to supply data that fits into an existing system. And that's why these open access methods repositories are of equal importance, because if we put our methods there and we push for these methods to be put on United Nations Goose system, it's going to outlive SDG. And I assume NUTEC is going to outlive SDG as well. And so it takes something that is, so NUTEC is taking something that's a good notion and is turning it into something that's actionable and longer lasting than just the system of this is the 10 years of this indicator.
Thank you, Kishni, for your views, insights, about the uniqueness, of the platform on the NUTEC initiative. I'd like to thank you all, our panelists, for these interventions. And we still have some minutes now to go for the Q&A session. Then I would encourage you to don't be shy and take the opportunity of having these incredible panelists with us. Please go ahead. If you say your name, position, and country, please.
Thank you. My name is Tania Ramirez. I'm Director of Hazard the Ministry of Environment in Mexico. Thank you. And my question is to Carolina. And the question is how the ministries can work with the IAEA to improve the financial and technical opportunities for all these regional expertise. And also, what are the replicable lessons that we can offer from Remarco model to another regions with similar plastic pollution challenge? Thank you.
Thank you. Carolina?
Thank you very much for the question. Well, to start with the support from the ministries. I think that something that is always important for us is to have resources, to have availability of resources to be able to continue with our work. IAEA does a wonderful job helping us to develop capacity and to have improve the infrastructure in our laboratories, but all the resources that are needed to do the monitoring have to come from our own countries, and sometimes we lack the resources, and that limits the impact of this training and of this capacity that we are receiving, because we cannot expand too much because of the lack of resources. So what I would like to say is that ministries can help the region allocating resources for those laboratories that are doing this effort to collaborate with IAEA to improve the capacities of our nations. Because this is not a capacity for one laboratory in particular, it's capacity for our country, for the member state, and we think it should have much more support on that side. Talking about what experience from Remarco can be reproduced in the regions, Irene has mentioned something very important that I would like to reinforce, and is the appropriation of the methodologies. It was very important for Remarco to have the opportunity to develop the standardized methodologies, taking into account the reality where we were. Sometimes we are looking at the literature in things that we could do with beautiful oceanographic platforms that we don't have in our coastal towns. So we have to be able to put this capacity building into the reality in the type of resources that we really have in the region. And it takes for all the technology. We have to adapt the technology to what we can really keep working in our own regions. Another thing that I think is very important is to continue with the training. We need to be able to train our researchers, but secure that these trainings is follow up to make sure that all that they have understood, that they have learned in the first training course, we reinforce them often, and to follow up also with proficiency test. We have to demonstrate that we are able really to do adequate measurements of whatever we are measuring, and that we follow up with time that this capacity is really still in place all the time. And lastly, I would also recommend to have whatever has been developed in any region, to have a repository that can be revisited for the scientists that have been trained, but also for the new scientists, the new generation of scientists that wants to start working in the same topic, and that we revisited all this information also to update with the new knowledge that we are generating, or the new knowledge that is being generated elsewhere. I think that these are my key thoughts. Thank you so much.
Thank you, Carolina. Any other question from the audience? Okay. Then I have a question from my own, no? Just to keep the ball rolling, just some minutes more. But it's about you explain all this platform, the details, the access, etc. But I wonder, what are the next steps? Where we are able to introduce data to populate the platform? What are your insights about the next steps?
Certainly, thanks, Sol. So we're in the last stage of developing and finalizing the solution, and we're just fine-tuning some of the the very detailed aspects of the solution in terms of the development and the implementation. We're nearly there. What we need to establish is the proper governance and communications plan around it. The users globally need to be trained in terms of how to use the system and how we can make the best use of it. The system-wise, technically, we are more or less there. The only missing link is to do this API, the link interconnectivity with the UNEP global database, which is going to happen soon in the next couple of weeks. On the other hand, the member states need to be informed that there is such global platform available for their use, and at their national level, they need to nominate their respective laboratories along with their users and permissions and access levels so that we can define them in the system to make things simpler and easier for them. Once the proper governance, communications, and trainings are in place, we are planning to launch the system by the beginning of next year, early next year, I would say January.
Okay.
Thank you.
Thank you, thank you. Please go ahead. Jida? Yep.
Good morning. I'm an assistant professor teaching physics and water resources engineering here in the Philippines. Speaking of capacity building, if I may ask the whole panel for suggestions, whether there might be ways to tap the universities, undergraduate students in particular, mobilizing basically students to contribute to this global effort for data monitoring. Would any specific project suggestions that can be done at the level of undergraduate students? Thank you very much.
Thank you for your question. Would like to take it? As you like.
Thank you for the question. Actually, in the Philippines, we have a project that's been led by Dr. Deo Florence Onda. It's you can check it out. It's online. www.plasticcount.ph. So the effort is not just for graduate or undergraduate students, but it's actually for everybody. Anyone who wants to contribute data on macroplastics and microplastics can do so and upload the information, geotagged as much as possible, on the website. So we have that effort already in the country. And the goal is to contribute that information to the global system. Thank you.
Thank you, Irene. Any other question? Great. I don't see any hand raised. Then I'd like to thank our panelists and the audience. I think that today's discussion now have proved that the NUTEC Plastic Initiative is not just about science and technology. It's also about the collaborative spirit within all our institutions, the cooperation at every level, by any means, to make a difference through this global effort. Crucial challenges lie ahead of us were highlighted by our panelists, such as the need to improve our measurement methods, the lack of proper technology, analytical equipment in our labs, and also, of course, the mobilization of resources to support all these endeavors. But none of this happen alone, and IA will very much looking forward to joining hands with all of you so that our results can be scaled up, widely disseminated, and finally contribute to a more sustainable environment. ladies and gentlemen, thank you so much for joining us in this session.
Thank you so much, Mr. Saul Perez P1, and also our distinguished speakers, Ms. Ana Carolina Ruiz Fernandez, Ms. Keshni Pilay, Ms. Irene Barra Rodriguez, and Ms. Shigdan Bahadir. Ladies and gentlemen, let us give them a warm round of applause. We request our moderator and speakers to please exit on the right side of the stage so that we can give our small token of appreciation. Ladies and gentlemen, that concludes our session 4, and we'll be proceeding to lunch. Lunch will be served at the main dining area, so please enjoy lunch. But before that, we'll be hand over the microphone to Mr. Aihan.
Oh, okay. Hi, thank you so much. Please, as we invite you to lunch, this is just a reminder that most of what you have heard here just came from the printers this morning. We have a small brochure that I think you will like. It gives snips of what you have been hearing and what you will hear this afternoon. And a second item, over lunch, we will have an informal chat with our youth representatives on how they see the plastics issue as well. So please join us to lunch. Thank you.
Thank you.
Ladies and gentlemen, may we request everyone to please be back at the Forbes Ballroom. For in 5 minutes, we are going to proceed to our program. Once again, we are requesting everyone to please be back at Forbes Ballroom as we proceed to our next part of the program. Thank you. Once again, may we request everyone to please settle down as we are about to proceed to our program.
Check. Hello, hello. Sound, sound.
Welcome back, ladies and gentlemen. We now shift to one of the spotlights or one of the most crucial pillars of long-term sustainability, the youth. We are very pleased to have IAEA Director General Rafael Mariano Grossi with us in this session, interacting with the representatives of the next generation. To guide us through this important segment, we invite our moderator, National Chair, Committee on Environment and Ecology of United Architects of the Philippines Students Auxiliary, Ms. Nicole Angela Ramos.
Hello, everyone. I wish that everyone has a good afternoon and had a fulfilling lunch with others, other nuclear advocates as well. So I welcome my fellow students here in front of us. Can I get a hi from you guys? Hello. And we also have other professionals here, which I hope that this session would spark different initiatives to the professionals and embed knowledge to the youth as well. So, ladies and gentlemen, good afternoon. As we convene for the International High-Level Forum on NUTEC Plastics, we acknowledge that the challenge of plastic pollution requires nothing short of a global, multidisciplinary, and intergenerational response. The IAEA's NUTEC Plastics Initiative is groundbreaking, bringing nuclear and allied technologies into the forefront of research and remediation. But technology alone isn't enough. We need passion, policy, and persistence. And that comes from the youth. My name is Nicole Angela Ramos, once again, and I have the privilege of serving as the National Chair for the Committee on Environment and Ecology of the United Architects of the Philippines Student Auxiliary, and my work focuses on integrating sustainable design and ecological principles into the built environment, a sector crucial to minimizing plastic use and optimizing waste management. It is truly an honor to guide this session. In this session of the forum, the IAEA passes the microphone to the leaders who will inherit the planet, the youth. This segment is about engaging the energy and ingenuity of the next generation in tackling the global plastics crisis, particularly through the fascinating lens of nuclear science. We are honored to have here today the Director General of the IAEA, Mr. Rafael Mariano Grossi, to share his insights as well. To set the stage for our discussion, I'd like to invite the Director General to deliver his opening remarks.
Hello, everybody. Good afternoon, and thanks for coming to this part of the forum, which I hope will allow us to have a discussion that, if I may, Nicole, will go a little bit beyond, although we are going to be talking about NUTEC plastics and recycling and things like this. But I think, considering that we are talking to the new generations, those who are already, because most of you are professionals, already working or completing your studies at postgraduate levels or close to that. I think it's important for me to explain what is the sense and the meaning of what we are trying to do with things like NUTEC. And as I said, going beyond it, which can be also seen as a way to explain how international organizations, big institutions, can articulate their missions in a way that is really a practical solutions to real problems, which I imagine is something that we all want to see from big institutions, and in particular from international organizations. We are living in a world which is complex and difficult, and where a number of problems and challenges appear before us, but we also have instruments, methodologies, science, organization to address them, hopefully in a good way. And this is what inspired us to try, from the IEA, to articulate the science and the technology that we have in a way or through instruments, if I can call them like that, or initiatives, like NUTEC, that would allow us to go faster and more effectively into problems, and in a way that it is hopefully impactful. Why I say this? I say it because, of course, I did not invent the IEA. The IEA was established in 1957, all right, long time ago. And the IEA has a very good tradition of doing a lot of science in different areas, all right? For those who like international politics, among you, you will see us, dealing with nuclear proliferation issues in Iran or in the Middle East or in North Korea, or on matters related to nuclear energy. So those are parts of what I call the hard agenda of the IEA, and this is very important. But of course, there is this other aspect of our work, and perhaps your work, and we'll be hearing from you, what are you doing in your different countries, in the places where you live, where you work, where you study, which has to do with this, with the application of this, in our case, of nuclear technology, science and applications, to certain problems. And as I was saying, yes, the IEA was doing that, but my perception when I became Director General of the IEA was that there was a bit of a dispersion of efforts. We have something which is our technical cooperation program. We have the science, the technology, and then you have an operational arm, which is this technical cooperation program. There is money, and this money is allocated to projects in different parts of the world, projects that need to respond to a series of parameters in order to be eligible. But in my view, and in the view of the team, we could do better than we were doing, in the sense that some of these big problems that we clustered in a certain way, and I'm going to try to explain, and this is one of them, NUTEC is one of them, not the only one. We needed to arrange them in a way that would do what I was saying before, that would bring the science, the knowledge that we have. You have been hearing from our experts. Many of them are here. They came with me from Vienna. They are delivering in different areas. But we have all these nodes of expertise, and this needed, as I said, a more impactful organization. So, for example, when it comes to human health is an area where the IEA has a lot to do, in particular in a big area, which is radiotherapy, cancer, oncology, nuclear medicine, all right? So, for this, we created a program which is called Rays of Hope, and through Rays of Hope, we developed a tool to try to basically, and put in very simple terms, bring radiotherapy when there is very little or none, because there are many places in the world where we have basically nothing. So people die, they don't even know that they have cancers of which nobody dies in Europe, where I work, or maybe in the Philippines, in Manila, or the big urban centers. But this is one thing. In the area of food, so we establish atoms for food. And of course, when you say food, there is in the UN family, because we don't have to, that's one of the problems of the UN, bloated bureaucracy. There is an organization which is called the FAO. You may have heard of it. It's in Rome, the Food and Agriculture Organization. So we joined forces with them. And what did we do? We organized our science into different services that we can provide. Have to do with irradiation of food to make it durable, sustainable, not to go rot, basically speaking. We organize ourselves in something which is called the sterile insect technology, which allows us to control and eradicate diseases like dengue or tsetse flies or chikungunya, things like this, all right? And also protect crops, fruit, things that are very valuable. That was another. Or looking into ways to utilize radiation in a way that strengthens crops, make them resistant to drought, to heat, to the problems that we are seeing in the world, so that we can increase the yields, for example, of rice here in Asia or in Africa, cassava, or things that are staples of the population. And like this, as I said, services. It's like you come to the IEA and then you have the menu as a country and they say, well, I have a problem in food or agriculture, and how can I avail myself of these certain services and technologies to do something. So, of course, COVID was a shock for all of us in every possible way. And so we asked ourselves, first of all, we distributed RT-PCRs machines. These are nuclear. People sometimes forget that it's basically a nuclear technology that went into this. But that was, of course, you remember, perhaps now we have forgotten, because when things come back to normal, we are fast to forget about the hard times, but remember 2020, the lockdowns, people dying, etc. People not knowing, do I have it, it's a cold, or it's COVID, what is going to happen to me, etc. So first was the machines, but then we said, well, then we will have to do something else. And of course, with nuclear techniques of identification, we established Zodiac. Zodiac stands for Zoonotic Disease Integrated Action, Zodiac. And through Zodiac, we have been working, equipping labs, veterinary labs, in many parts of the world. In Africa, here, where the biodiversity is very strong and the interaction between humans and animals is very, very, very present. So we have been working with them, trying to establish channels of communication and so on. Of course, in the area of energy, and last but not least, environment. And in environment, there are many things we do, but we thought that given the dimension of the problem of plastic solution and the ability of nuclear to do what you have been discussing for these 2 days, in the head end and tail end of the problem. So first of all, the identification of the problem, tracing down the problem and in the ways that you know, and I will not repeat, and then doing the recycling. So these remarks, Nicole, are to say that we at the IEA, we believe in science as service. Science should not necessarily be service, but for us, yes. Of course, there is pure science, there is research. We do some research, which is conducive to action. But basically, and one day, I hope you will have the possibility of visiting us in Vienna to see really that the IEA is an organization like no other. Not because it is better, it's different. And so apart from a big building with offices and people working inside, we have a campus of labs, a huge campus of laboratories, where all the science that is underpinning all these projects that I was talking about is done by scientists. Some of them are here, and they came to explain what we are doing. So basically, this is the offer. This is what we have been trying to do and what we are going to be trying to do in the future. Perhaps as a curtain raiser, this is enough. I really look forward to listening to you, to listening to your experiences, how you're doing, what is it that you are doing, and perhaps, of course, having partnerships with some of you and your organizations to do this mission, which is a good one. And I stop here.
Thank you so much, DG, for those inspiring words. I agree that nuclear is more than just the misconceptions of the people have nowadays. Its approach in various issues is multifaceted. As a witness of it, I'm actually an advocate in the Atoms for Climate campaign and was asked to release a statement about it. And now that we have everyone here with us today, let me introduce to you the youth representatives that I'm sharing the stage with. Let's start off with Mr. Von Tobes.
Hello. Good afternoon, everyone. I am Von Michael Tobes. I am a political science, international relations, and foreign service and economics scholar. I am the founder of 0 Hour Philippines and director for Asia at 0 Hour. I am also a global ambassador at Earth Day Network. And I am also a member and youth negotiator with the Children and Youth Major Group to the UN Environment Program and a co-lead of the Youth Plastic Action Network. And I'm also a youth representative for the Philippines at the World Food Forum of the FAO.
Okay, now next we have Vince. Vince, kindly introduce yourself.
I'm Vince Chen from St. Jude Catholic School. I'm currently finishing my studies. I'm grade 12 right now, in my last year of senior high school. And I joined this forum as a way to connect my studies, especially since my studies is mostly theoretical, to more practical solutions of how these nuclear technologies can create real sustainable solutions to our current problems, specifically plastic pollution.
Thank you so much, Vince. Now we have Miss Natalie.
Thanks, Mr. DG, for being in this session with us, and thanks to the IEA for hosting us. My name is Natalie Bernard. I'm from Argentina. I did my PhD on microplastic pollution in Antarctica, and I became part of NUTEC almost 3 years ago when I first came to the Marine Environment Laboratories in Monaco to get training on the use of nuclear techniques for the analysis of microplastics. But in the end, it became much more than that, and together with the team, we have analyzed thousands of samples and reported microplastics in many regions of the world, which I hope will help policymakers to take informed decisions towards this problem.
Thank you so much, Miss Natalie. Now we have Danielle with us today.
Hello, everyone. I'm Jan Daniel Bonita, a Technical Cooperation Fellow from the Philippines. Prior to becoming a TC Fellow, I was working with the UP Marine Science Institute, who has been on the front lines of marine plastic research in the country. And currently with the IAEA, I'm trying to contribute to the pioneering efforts to investigate microplastics in bottled drinking water.
Thank you so much, Danielle. Now we have the last but definitely not the least, Kekali.
Thank you. SMSCDG and participant, it is an honor for me to take part at this international high-level forum on NUTEC plastic. So my name is Kekere Kodjo Morel Aziade. I'm come from Togo, a first young African expert in microplastic pollution trained through NUTEC plastic. I'm a PhD candidate at University of Lomé, working in microplastic in sand, beach, seawater, sediment, and biota. And I'm member of laboratory treatment, recovery, and waste. Thank you.
There you have it, our youth representatives for this afternoon. Thank you so much, Vince, Vaughn, Daniel, Kikeli, and Natalie, and of course to DG. Now, before we start answering their questions, I would like to gauge the audiences first with our topic. Are you guys familiar with the NUTEC plastics? We'll find out by scanning the QR code. We'll be using the Mentimeter to assess whether you guys are familiar or not with the NUTEC plastics. So the tech team, kindly flash on screen our QR code for the live poll of their familiarity regarding the NUTEC plastics. Please be advised that as the QR code is flashed on the screen, you guys are encouraged to scan it via your phones and vote on the poll, which says yes or no. The tech team. I think they're having kind of technical difficulties. So I'll just ask everyone, raise your hands if you guys are already acquainted or familiar with NUTEC plastics. Okay, I think most people on this side are familiar. They're working on it. However, on this side, are you guys familiar with NUTEC plastics, or are you guys new to it? Have you maybe scrolled down the IAEA's webpage for you guys to have an initial knowledge about it? So I think the students here are nodding their heads. So I think they're kind of familiar with NUTEC plastics. However, DG, I would like to ask a more or a deeper insight regarding NUTEC plastics for those who have just a shallow insight regarding it. So what is NUTEC plastics all about, really?
Well, there are two things, and still trying not to get, I'm going to go deeper, but not as deep as to become too scientific in the answer. To say that, first of all, I think you were saying it, Natalie, we need to have policies, you need to understand the problem. This is fundamental. And when you have problems related to the environment, it's only on the basis of data collection and evaluation that you can determine whether the problem is worthy of public policies, whether the amount of effort that needs to go into solving that problem, and what are the best instruments to do that. They could be through international cooperation, regionally, nationally, and at national level, could be local or bigger. So in the case of NUTEC, you have two ways. The first is, of course, through radio tracers and some other techniques that you might be able to explain even better than myself. You identify the composition of a water sample, how much plastic is in it, what kind of plastic is it. You can even, in some cases, determine the origin of that plastic. And you can even go to very small levels in scale, from micro to nano, and really go into determination of the presence of plastic. And not only, as some of you said in the description of your work, not only in water, sediment, biota, sand, in all the places where you can collect any residues in this case of plastic. And then there is the recycling. Recycling of plastic has unfortunately it is not even scratching the surface of the volume of the problem. Some statistics that I have read, maybe updated or not, talk about recycling of only 9%, more or less, of what is dispersed into the nature. In the case of seas, 20 million tons per year. So, and you may have seen it, I'm sure. You have seen these documentaries or images that are quite impressive and really eyesores in some cases in terms of the presence, the surface of plastic. But the problem is more pervasive and sometimes less visible or invisible, because unfortunately in the water you have there is plastic. That is a fact. And this is why we need to go to these levels of disaggregation to identify the problem. And in recycling, of course, through irradiation, the capacity to transform the structure of the material and turn it into something else, something that you can use for something different. Today, I had the pleasure, I don't know if this is part of the program, but I had the pleasure to visit a house made of plastic. You went?
I'm actually going with everyone else.
You are going to?
Yes.
Okay. Well, it's quite impressive. And of course, this has to undergo some evaluation in terms of the resistance, temperature, and some other things that the Philippines Nuclear Research Institute, PNRI, is going to undertake, or is undertaking at the moment. But there we can see in a very concrete way how, as I said, in the beginning of the problem or in the head end of the problem, what is my problem, and deriving from that what kind of solutions. And one way to recycle, there are different ways to recycle, but one way could be this. So, and NUTEC also fosters international networks of cooperation and information sharing, which is crucial, because what you are doing in your national labs has to be cross-checked and benefits a lot from what peers in the other side of the world may be doing, or discoveries that there might be, or problems that they may be facing. This did not exist, and the IEA created a global laboratory network that is at the moment already operating and collecting information, sharing it with different labs and organizations around the world. So this is more or less what NUTEC is all about.
Thank you so much for sharing a deeper insight about NUTEC Plastics Initiative, DG. And now let's move on to the main discussion, where our youth representatives here on the stage will pose their questions to you. We'll start with Mr. Vince Kenrich Chen. Mr. Chen notes that the application of nuclear science to environmental challenges is fascinating, especially since most people don't associate nuclear technology with plastics waste. Usually, high school students just craft plastic bags or maybe turn them into Christmas lanterns for a project. That's the typical use of plastics as an upcycle. But Mr. Chen here will elaborate his question.
Yeah, so adding on to that, nuclear technology is also widely known for its use in nuclear energy, medical fields, and more. However, for plastic pollution, I'm sure that nuclear technology is less known for it. So my question would be, what are some the flagship projects of NUTEC Plastics, and how is nuclear technology used in these different projects to combat plastic pollution?
The question would be directed to you, DG. Yes.
So your question is, what are we doing, or what are the problems?
Oh yes, like the projects, the flagship projects that IEA.
Yes, yes. Well, as I said, you know, how we do this is when you have the scientific pillar, then you have to spread it and make it operational in different parts of the world. And to do that, we have a technical cooperation program. This technical cooperation program is a program which works both ways, in the sense that, in principle, it's always driven by the client, between quotes, which is countries or their institutions. The institutions oftentimes they come to the IEA. They say, we have this issue or this question. We would like to benefit from support. This support has, again, can be disaggregated into different things. In some cases, it can be applied to NUTEC, of course, and is applied to NUTEC, but in all of the other programs I described to you in the beginning, it's the same. It has the specific projects. It has the capacity to share technology and equipment. When you go to different labs that work with us, you will see equipment that has been donated by the IEA. Spectrometers, I don't know, advanced microscopes, different types of things that we donate, and we teach people how to use it. And then capacity building. Capacity building is training. We train scientists. We bring them either to Vienna, to these labs that I described, or we come. And sometimes when there is a specific problem, we send like a task force to try to address a concrete situation. Not so much in plastic, which is more of a structural problem that is getting bigger and worse, if you want, but sometimes, often in some other issues like atoms for food, for example, there is a plague, there is a problem, there is a wilt that is attacking a crop. This has happened to us. So we go and we try to apply certain methods, and we try to solve it in a certain sense. So this is the way in which we try to organize ourselves to go into the solution of problems. I don't know if that was more or less what you were interested at or not.
Oh, yes.
All right, yeah, good.
Yes, I hope that DG was able to answer your question, Vince. Thank you, DG. The NUTEC Plastics Initiative is actually motivated by the severe microplastic crisis. It offers a dual nuclear solution by using radiation technology to make low-value plastic recycling profitable, and employing nuclear techniques to precisely monitor microplastics pollution. This strategy firmly establishes nuclear science as crucial two-part tool for building a circular economy. And now for the next question. This question will be posed by Mr. Von, who is engaged with the Zero R in addressing plastics pollution. Von, can you share your thoughts with us?
So my colleagues here are scientists and researchers, while myself is in the policy advocacy side. So I want to give context and a deeper background before I ask my question. So central to my advocacy has been visiting and engaging with far-flung communities across the Philippines. Rural and remote communities and mountain and island barangays in some of the poorest provinces in the Philippines barely have access to electricity and almost no access to internet connection. Yet they are plagued by the plastic pandemic. In 2021, before the adoption of UNEA Resolution 514, I was an ambassador for the Beat Plastic Pollution campaign of Mesh Mines and the UN Environment Program to highlight how the Philippines and Southeast Asia are hotspots for marine plastic pollution that is killing our marine ecosystems and the communities that depend on it. For 3 months, we were able to engage and inform over 20 million people worldwide. Beyond that, I have been an advocate my whole life, engaging in dialogues and organizing workshops and talks with my fellow students and young people. I have organized hundreds and engaged thousands across the Philippines, especially far-flung communities where access to the internet is scarce and educational materials are not quality. I continue my advocacy on climate and plastic action today by engaging young people in my personal projects, zero-hour programs, and through the Children and Youth Major Group, the UNEP, and the newly established Youth Plastic Action Network, which serves as the engagement platform for young people in the plastics treaty negotiations and its future treaty. Plastics are now found inside our body. The most recent study found microplastics in the womb, which was supposedly the safest place for humans. Young people must take action because the next few years are defining years of what our future would look like and whether or not we're leaving present and future generations a world where they can flourish. I am here not just because I'm a dedicated advocate and out of passion, but because for many like me and frontline communities, advocacy is a means for survival. Like myself, who is involved in the plastics treaty as a negotiator, many young people are taking action from multiple fronts like policy, humanitarian work, science and technology, and many more. With projects like NUTEC Plastics, young people now have more opportunities to take action. DJ Grossi, how can the IEA effectively engage young people to take practical action in addressing the plastics crisis through the use of nuclear technology?
Well, one way is this. I think the effort should be, and we try as much as we can, to structurally speaking and institutionally speaking, to engage with the institutions that are responsible for the sectoral problems we are dealing with. This, let's not forget, this is a partnership. It's not a, top to bottom thing where the IEA is somewhere up there and we are telling people what to do. It's a relationship that we have with our member states. So I know in the Philippines, for example, with whom we work. With whom we work. When it comes to science and technology, there are a number of institutions here in nuclear and in other applied sciences or in human health. And then we have our national liaison officers, and then there is this. But what you say, I think, is very valid in that there is an imperative to, obviously, not easy always, but to integrate the new generations. Could be young or less young. In your case, you are all professionals, so it's not a vocational thing. I see it more as an interaction with those who are starting and that are benefiting also because we have to pass the baton, all right? That is, I hope to be around for some time, but I know that I'm my life, I'm in the last segment. I hope it's not too short, but you are going to be doing this in 20 years, in 25 years, or in 30 years. That is an obvious thing. So I think here it's a call not only for the IEA, but also nationally, so that scientific institutions are, in some cases, it is structural, because when it comes to institutions that do high-level research in science and technology, well, this is the normal educational path that you are going to have, and you're going to be feeding into the process the new generations. But I guess that as far as we are concerned, we try to have interactive dialogues like this wherever I go, at least, or wherever we go, to attract people, to explain. Our area of work is one that requires a lot of explaining. And I'm not thinking about this particular area. I'm thinking mostly about nuclear energy. And in this country, there have been lots of polemics about nuclear. Nuclear is bad, nuclear is this, nuclear is that. So we are trying to foster this culture of, of course, the serious dialogue, not a militant or stupid or, you know, we try to keep it in a level that is, you know, of intellectual honesty, first of all, that you can have visions or views about certain technological solutions that can be juxtaposed or contradictory. But I think this is important. And being you a political scientist, and as I can see, already engaged in negotiations and in processes, I think that is quite clear to see where these processes are taking place and where not. But as I said, here there is a big national responsibility to integrate, to have a healthy institutional process. And in some cases, it doesn't exist. Or you see the same people all the time. So, yeah, that would be my take.
Thank you so much, Juan and DG. I think that the saying that it takes two to tango here is applicable. Just like the IAEA is working their efforts on creating these initiatives that help tackle the various issues that the world is facing right now. I think other institutions and organizations should also play the role of empowering the youth to partake in these kinds of initiatives. That's why it is important to involve the youth, since we are the future of initiatives like these. Some days, maybe the next Director General would come from this audience. That's a maybe, that's a guess. And I think by being involved in these kinds of conferences, informative conferences that we have, especially when the DG is here and other experts are here, we are able to expound our knowledge and be more acquainted about it, so we can advocate and tell other people about it. So aside from involving the youth here and empowering them with the knowledge that they have to share with other people, we also have to tackle the circumstance or technical side of nuclear plastics, which would be asked by Mr. Daniel.
Okay, so earlier you touched on the topic of the importance of nuclear technologies in plastic research. And I definitely agree. I mean, nuclear technologies have proven to be instrumental in, one, identifying the scope and the scale of the pollution, and the second one is the finding solutions against plastic pollution. But I think there also needs to be an emphasis on not just on the nuclear technology itself, but the people who will be optimizing, validating, developing these technologies. So my question is, what are the efforts of the IAEA when it comes to building skills, building capacity, and building expertise, especially among the youth, the young professionals from its member states?
Well, yes, indeed. And as I explained in one of the previous answers, we have different ways. One, of course, transferring equipment, technology, and I refer to this capacity building. We have a number of regular courses, trainings, depending on the area, applied to seminars and for symposia, where, of course, we tend and we try to attract new generations. But again, as I said, we can do that much. I don't like to pretend that we do what we do not do. We can do that much. I think national institutions have are partners in this and have to do their part. What we need to do is to provide the vehicles, provide the products, provide the spaces where these things can actually take place. And to the extent possible, because it's at the end of the day, nationally and internationally, it's a matter of resources, unfortunately. Who pays? We can have lots of spectacular ideas, but at the end of the day, resource mobilization is tremendously difficult. It's very, very, very difficult. And this is why what we need is countries to partake in the effort and to contribute. And although this is not about that part of the issue, we have been trying, and I mentioned this in this context because you were asking, well, what do you do to bring more in? We are a scientific, technical, political organization. We are not in social construction or anything, but it is obvious that in this area, opportunities for women are scarce. And this is scarce. And this is why we came up with specific programs. For example, we established the Marie Sklodowska-Curie Fellowship, which did not exist. And now we are approaching 1,000 women that have mainly, if not totally, young, new generations that did not have from Africa, Latin America, the Caribbean, Asia, that did not have the opportunity to pursue graduate studies, and thanks to this program, they were able to be integrated. So, whenever we can, we try to look into what could be articulated in a way that would enlarge the pool of talent that we can integrate in the work of in science, and in particular in nuclear science. And in our case, it is important because nuclear, as we've seen, can be nuclear engineering, but it can also be radiotherapist, or it can also be someone who is working in plastics, or it can, all of those specialties, or in food research. So it's one of the ways.
Thank you so much, DG and Daniel. And I agree that fellowship programs like the Marie Curie Fellowship Program, which funds scholars, right, to pursue careers in the nuclear field, is helpful. And by empowering or investing in human resources, the IAEA builds a resilient, distributed network of experts essential for tackling the future global challenges. And now, moving on, we have Kekeli here, an IAEA fellow. Mr. Azeade, you've experienced the capacity building of NUTEC Plastics firsthand. What is your question regarding its long term?
Okay, thank you. So the IAEA has developed numerous flagship initiatives such as NUTEC Plastic and Zodiac to deliver a scientific solution globally. So my question for DG now, it is how does the IAEA plan to use nuclear science and technology to tackle globally issues like climate change and pollution beyond its flagship initiative like NUTEC Plastic and Zodiac, in particular in Africa?
Well, in terms of climate change, I think we are present at both, that the climate change analysis and action internationally has been formulated through two axes. One is mitigation and the other is adaptation. This is a bit of jargon, all right? This is jargon from the Convention on the Framework Convention on Climate Change. And structured through the COPs. I suppose you are familiar with the conferences of the parties of the Climate Change Convention. There is one every year. There was one just now, which ended in a not so optimistic tone in Belém, in Brazil, just last week, which was the COP30. I refer to this not to talk about conferences and meetings, but just to rescue the analytical lines. So, and here I think it's very clear where nuclear or the IEA is present. Mitigation is obviously nuclear energy. And here, you know, to reduce the fossil fuel use and the imprint of carbon and dioxide emissions in the world. And here it's very interesting, you know, because here you have seen an evolution of the international debate and discussion. A few years ago, if you went to a COP and you said that you were from the nuclear sector, you would not be well received. This is very scientific and regrettable, but that was the case. There is a lot of intolerance, even among scientists sometimes. So they say, no, nuclear is horrible, this and that. But it took 28 COPs, and at the 28th, which was in Dubai, the final document or declaration, however you call it, said that nuclear should be accelerated. And this was said not only by those who have nuclear, but by everybody, simply because the analysis of the IPCC, again, sorry for the acronym, is the International Panel of Climate Change, which is sort of Olympus of scientists from all over the world that are specialists in climate change and their effects. Well, they came simply to the mathematical conclusion that if you want to get to where we collectively want to get, reduce temperatures, go to more carbon-free energy matrices, etc., without nuclear, you're not going to be able to do it. As simple as that. So, mitigation, you may or may not do nuclear. That is another problem. That is another discussion for another panel. But that is mitigation. And adaptation is some of the things I refer to, in particular, in this other program we have, which is, of course, Atoms for Food. But not only, because this as well, when it comes to the environment, and when it comes to all the results of the abuse of plastic and things like this, but in particular, or more directly, when we address how we produce, how we live, how much water, especially in Africa, how much water we use. You know, this concept of smart agriculture. Smart agriculture is science-based to use less water, and this is done in a series of scientific ways. So this is how we do it from each axis, and there are others. As I said, you know, the IEA is not the alpha omega of every problem in the world. We are trying to show from our perspective, with our tools, with our instruments, how we deal with these problems, and it's quite effective. Honestly.
Thank you so much, DG. And now to ask our last questions from the youth representatives. Natalie, would you mind to share your question with DG?
Yes, so Mr. DG, last year you traveled to Antarctica, where together with the government of Argentina, you launched the NUTEC plastics mission there. After that, scientists from both IAEA and Antarctica have been working together to produce data and fill this huge gap of information we had about microplastic pollution in the region. So this, together with the Memorandum of Understanding that you've signed with Argentina that shows that this research will continue, are clear examples of NUTEC success stories. So my question for you would be, what do you believe are the biggest achievements of this mission, and how do you imagine the future of this collaboration?
I would like to hear you on that one, honestly, and perhaps you can say something. But you know, what we believe, what prompted us to do this, and if I understood correctly, you started your work in this area before this mission took place and all of that, is that we thought that there was insufficient attention to the problem. You not, so perhaps we were not so off the mark on that. So, and that, of course, Antarctica is one of those few places in our planet where we have organized ourselves through the Antarctic system in a totally cooperative way. We don't have many space, but less and less. And in Antarctica, through the Antarctic system, we decided back in 1959, I think it was, that we would make sure that this is a space where we have to keep it pristine and can only work cooperatively. This is why there are no military activities there. But we wanted to show and to showcase that even this environment is suffering from the problem that you have been looking at. There have been already some publications, I believe, as a result of that project, and we intend to continue. Interestingly, other countries in our part of the world took interest in that, and so this is the kind of I would say, positive demonstration effect that you can generate, and it is something that I'm hoping to have also in your ASEAN space. In Africa, it's obvious that we need it at every turn. So the example of the missions to Antarctica, it's also for the policymakers. An issue of getting the attention of the policymakers. Because without that, you may be doing very good things, but the impact would be less. In my case, it was easier for me because I happened to be Argentine, and I asked to the then newly elected president, how about this? You want to come? And he was interested. Of course, who wouldn't be? It's a fascinating topic that you chose. And this is very important in your public action. And it's not always easy. And I think if a guy that has been around for some time like me can pass something to you, is this important element of interaction with policymakers, which is sometimes so difficult, especially in developing countries, where science, technology, and research are not necessarily priorities, and where, of course, public funding is not unlimited and has problems. But well, I will ask you more about how this is continuing, because I want to check. And you have our guys here. I think you were working with them, and it was a very inspiring mission, of course, for us at the IAEA.
Thank you so much, DG and Natalie. Now we open the floor for questions from our live audience. Now for our students here and other people who are also with us today, kindly raise your hand if you have questions. We'll entertain 2 questions from the live audience. Are there any questions from the youth here? I can't see on this side because the light is too bright. So I think I might need help. Okay, we have Mr. here. Kindly give him a microphone.
Good afternoon, everyone. So I have a question. I am Toby Abitria from San Francisco High School, grade 12. So what reference points, baselines, or key performance indicators can be used to demonstrate and verify progress in mitigating plastic pollution, both locally and internationally, through the use of nuclear technology?
Can anyone in the panelists share their insights about his question? I think, DG, this one is for you. The question is especially for you.
Can you repeat the essence of the question? You were speaking so fast, and there's some echo.
I'm sorry.
There's a lot of echo here. You may have noted, and it's sometimes difficult to understand. So please, slow and clear, and I will try my best.
Okay, so I will repeat my question. What reference points, baselines, or key performance indicators can be used to demonstrate and verify progress in mitigating plastic pollution, both locally in the Philippines and internationally, through the use of nuclear technology?
Well, it's a very specific question, the one that you are asking, as in any scientific endeavor, you have reference points which are applied and which have to do with a number of things. The immediate impact on the specific environment you are looking at, the phases time-wise and otherwise that you are looking into. Is scientific methodology that you would apply. And I think and I was right, that is a question more to the scientists here than myself. I have a policymaker perspective on that, which is basically aimed at trying to understand the real impact of what is happening. And it is my scientists and the scientists that help me understand the problem on the basis of a number of parameters, as you rightly mentioned.
Thank you. Now for our last question before we close this segment. Are there anyone else? Okay, for our last question. Okay, there's a lot of hands, but I think the one in front here could ask his question. Okay, they also selected one at the back. Okay, so I'm so sorry. They've already selected. Okay, go.
Good afternoon, everyone. So I'm Neil from De La Salle University. So I think this question would be of interest to most youth, especially those in high school and college. So what are the research opportunities for students who might be interested in having any research related to the topics discussed today as well as yesterday on mitigating and solving the problems regarding plastic pollution through nuclear science? Because this is a relevant topic, and the innovations that are present in the exhibits outside are very helpful. And if they become more efficient, then we can upscale them so that countries can make policies that implement them and so on and so forth. But basically, students need to start somewhere, with regards to researches. So what are the possible researches that they can do, especially high school students and undergraduate students for their thesis perhaps? And then what can the IAEA or even UN in general can do to help these students who are interested in making these researches? So I'm very sorry if the question is long.
It's not necessarily long. I think we have addressed it in different ways in all our interventions. I think, first of all, from my perspective, and I think this is just as I was saying before, it's a partnership. You're a teacher yourself, professor?
Student.
Student yet. Okay, but this is where the educational community must work in, I would say, if not in coordination, at least with coherence. I think when possible and when studying science, the orientation towards the comprehension of the world and the problems that we have is, from our perspective, very important. Again, it's not the only perspective, because you have, and this is very noble, the pure science, okay, the pursuit of the truth through scientific specialties. Can be physics, can be mathematics, can be social sciences as well. And this is absolutely necessary. But when it comes to this connection of our activity with the world, I think it has to be, or it can be, and it can be a very effective way when teachers, professors, educators in general can make this connection, which is tremendously powerful, at least in my experience with the young generations, even from primary school level. When you understand that there is a problem, that this is the beauty of science, among many others, that there is a problem that you can analyze, that you can disaggregate, and with the instruments of the human knowledge, you can solve it. You can make it better. You can make it more useful for a better life, which is in fact what we all aspire to. So, and again, you talk about the IEA. The IEA tries to, but again, there is in the world a division of labor. We are not a university. We are not an educational institution. We are a scientific, technical, and also political body that is there to do a number of things. But we recognize this intersection that sometimes exists between what we do and the purely educational part of it. Education is all. We know it. And I thank you for your question.
Thank you so much, DG. If you want to access educational tools, especially in the Asian region, we actually have the Asian Network for Education for Nuclear Technology, I think the ANET. So you can access their website if you want to learn more about the nuclear, especially in the Asian region. And now we have our last question from our fellow here in the front. I think he became shy. I'm so sorry for earlier. So come on, ask your question to DG.
Good afternoon. I would like to raise a question related to one of the topics highlighted in our university's International Research Colloquium held last October. We facilitated it as student leaders from Mapua University. So one of the major issues discussed was tire pollution, specifically how rubber abrasion particles gradually infiltrate soil layers and eventually contaminate natural water bodies. This pathway of macro and microplastic pollution is increasingly gaining attention in environmental research in the Philippines. Given that NUTEC Plastics already advances technology for tracking the abundance and distribution of micro and nanoplastics through isotopic techniques, I am interested to know, or we are interested to know, has the IAEA began addressing this particular challenge of tire-derived rubber abrasion pollution? Are there ongoing projects, research initiatives, or planned programs that specifically target this source of microplastic contamination?
Perhaps I would ask one of my colleagues in the area to address. I would not be able to tell you whether the IEA is specifically addressing through a specific program those areas that you mentioned.
I
Somebody?
think we have Sir Mark there
Yeah,
to answer
Mark,
the question.
s'il te plaît.
Yep. Yeah, well, step by step we are going to that. So basically we are in the process of developing the technology, and when it will be mature, we'll go for more transferring the knowledge. So we just published a scientific paper about the issue, because this is an issue that has been raised by our member states, and definitely this is the way forward. So we have the technology, we have equipment for doing this, but we need to work on that to be sure that the technology is mature to develop more projects on that.
If I may add something to that, rubber is a tricky polymer, we know that, but we are working towards developing methods that will allow us to identify and understand what this problem means. We're working on it.
Does that answer your question? Yes. Thank you so much, Sir Mark and Natalie, for answering the question. Thank you also, DG. And for those who would like to ask their questions, you can actually approach the experts on this side, especially for those students, if they have questions. You can have the opportunity to approach them, ask them about your questions. And now, thank you so much, everyone, for participating in the Youth's Voices on Plastic Solutions. For the closing remarks, can I ask the last question, DG, again? In the span of 5 to 10 years, where do you see the role of the youth in terms of the nuclear field? How do you see the role of the youth in terms of nuclear from your vision?
Here in the Philippines or in general?
You can start in the Philippines and then you can also discuss the global scale.
Well, generationally speaking, nuclear is very interesting because we come from many decades of a negative approach to nuclear energy. Of course, there were many people, and here in this room, there are many very successful professionals that have been working in nuclear technology and science, and many countries were doing a lot of nuclear, all right? This is one thing. But sociologically speaking, and this is very interesting because we see that when we analyze the workforce in nuclear, there is a certain gap because, 10 years ago or 15 years ago or 20 years ago, in many countries, including the leading nuclear countries, these countries were quite negative about nuclear. Not necessarily that they didn't want nuclear, but they were not seeing nuclear as something they wanted to continue with, or that the sector was not growing. So obviously, when you are a young engineer in any country, let's say countries that have nuclear, working in decommissioning a nuclear power plant is not very inspirational, is it? I mean, you want to work with things that are, not dismantling and, putting to sleep something, but creating something, working into the future. And now we see that the winds have completely changed. And it's not only in nuclear energy, for example, AI and nuclear is widely discussed. Data centers need energy, so obviously there is a frenetic interest in the AI sector, not in the nuclear sector, for nuclear, because they know that without nuclear, it's going to be very difficult to have data centers that all our countries need, all our lives depend on AI. People talk about, is it good or is it bad? Come on, it's been with us for a long time, and it's already determining our life in research, in banking, in health, in whatever we do. So now we see that there is a phase where people would like to work in this area. Here, for example, in the Philippines, and now I'm moving to the home country of this event, there is a lot of discussion. I was discussing with the president and with my scientific colleagues here in the Philippines. So they are thinking, are we going to rehabilitate the Batan nuclear power plant? Are we going to have SMRs? What are we going to have? And the same is happening in many, many countries. So I'm very optimistic about the future. Your generation, perhaps there is a little bit of a gap in the middle. People in their 40s, in their 50s, we don't have that much. And you will see in nuclear many people who are close to retirement because they were working in the good days of nuclear in the 70s and 80s before this sort of a slump came. And so it is more an analysis for sociologists and social scientists as to how this happened, the reasons behind, and how to mitigate that. But in any case, it is a very good phase, a phase where we see perspective for all of you, moving from school to university to postgraduate, you want to think about what is it that you want to do with what you are learning. And quite clearly, nuclear science application, not only energy, as I said, being in nuclear, it may also be curing cancer in radiotherapy. And it can also be running a nuclear power plant or studying a difficult polymer like rubber, or, many of the things we discussed today. But quite clearly, a good phase, a positive phase, which is all that you want and need when you are like you are, young.
Thank you so much, DG, for that positive vision of the future of the fellow youth advocates also here with us today. The message is clear, whether through scientific research, policy, advocacy, or grassroots action, the youth are central to the long-term success of initiatives like NUTEC Plastics. We will now conclude this session with a photo session with the Director General, all our esteemed panelists or youth representatives, and the student attendees. So please, if you must, kindly go in front since we will have a photo session with the DG. All students kindly go in front of the stage so we will have a photo opportunity here. The students will be here. Thank you so much, everyone. Kindly go here in front of the stage, everyone.
May we request our student attendees to please form a line here in front of the stage for a photo opportunity. Ladies and gentlemen, we encourage everyone to make it fast as we are running out of time. The count of 3, 1, 2, and 3. Smile. Thank you
There
so
you have it, everyone. The future of NUTEC. Thank you so much once again to our student attendees here who've joined us for today's session.
Once again, thank you so much to our moderator, Ms. Nicole Angela Ramos, and of course, our very own IAEA Director General, Rafael Mariano Grossi. At this point, before we head over to our final session, we'll be having a short coffee break. So ladies and gentlemen, please be minded that at exactly 3:15 p.m., we are supposed to be at the venue once again since we are running out of time. Thank you. Once again, ladies and gentlemen, we'll be having a short coffee break and we'll be back at exactly 3:15 p.m. Thank you. Ladies and gentlemen, may we request everyone to please be back at the Forbes Ballroom as we are about to resume our program. Once again, we are requesting everyone to please be back at the Forbes Ballroom for us to resume to our program. Thank you. Ladies and gentlemen, may we request everyone to please settle down. Welcome back, ladies and gentlemen. I hope you had a refreshing break. At this point, before we continue to our program, we would like to shift your attention to a project that represents one of the most compelling examples of innovation under the NUTEC Plastics Initiative. It's a glimpse into how science, industry, and sustainability comes together in a way that feels both practical and visionary. Ladies and gentlemen, the PREX Project.
The PREX project is redefining what's possible in sustainable construction. At the heart of this initiative is a simple but powerful idea, turning plastic waste into durable, high-quality building materials. It is led by PNRI in partnership with ITDI and Envirotech Waste Recycling Incorporated and supported by DOST, PCIEERD, and the IAEA through the NUTEC Plastics Initiative. The PREX project brings together science, engineering, and industry. The electron beam irradiation upgrades and enhances the properties of the plastic waste. These improved materials are then blended and extruded with other waste plastics and Envirotech, creating high-strength tiles, bricks, and boards. The PREX prototype house is a real structure designed to show how upcycled plastics can perform in every living conditions. It will be closely monitored to evaluate livability, structural integrity, and long-term environmental benefits. From customizable boards to plastic lumber and more, the PREX proves that with the right technology, plastic waste can be transformed into opportunity, value, and a cleaner future.
Once again, ladies and gentlemen, the PREX project. At this point, we'll be moving closer to our closing session. To navigate this final panel, please welcome our moderator, Acting Director of the Division of Africa at the IAEA Department of Technical Cooperation and also one of the scientific secretaries of this forum. Please welcome Mr. Gashao Walte.
Excellencies, distinguished participants, colleagues, ladies and gentlemen. It is my pleasure to welcome you to this closing session of the International High-Level Forum on Plastics. Over the past 2 days, we have collectively examined the progress, challenges, and opportunities associated with addressing plastic pollution through nuclear science and technology. This final session enables us to reflect on how we can further strengthen and shape the future direction of NUTEC Plastics, IAEA strategic initiative. The two dynamic pathways of action under NUTEC Plastics highlight the importance of upstream innovation, robust scientific evidence, coordinated delivery, and meaningful partnership. These elements have proved to be essential as we continue our support to member states in implementing science-based solutions. As we look ahead, the IAEA remains committed to supporting countries through a coordinated one-house approach. Through research and technical cooperation, we work hand in hand to ensure that innovations are translated into practical solutions towards sustainable impact. I'm very pleased to be joined by distinguished panelists this afternoon to share their perspectives on these future pathways. Ms. Selina Orak, Head of Radiochemistry and Radiation Technology Section in the Department of Nuclear Science and Application. Mr. Mark Metian, Research Scientist in the Marine Environment Laboratories at IAEA. Ms. Yoko Watanabe, Director of Environment in the Asian Development Bank. And Ms. Leah Bondea, Undersecretary for Research and Development in the Department of Science and Technology, the Government of Philippines. We can start our interaction. To begin with, I would like to invite Ms. Selina Horak to outline the future upstream activities under the NUTEC Plastics, including the technological pathways and the planned progression of radiation-based approach. Ms. Selina, you have 6 minutes. You can proceed.
Thank you very much, Gashao. Can we start with the presentation, please? No, it's the other one. Okay, what we are planning to present in this short presentation, 6 minutes counting, is that what are the main achievements, what were the expectations, what are the main achievements, and what are the main domain that we are planning to present for the next activity for the next year, in the upcoming year. Not coming yet.
Ready. Okay, due to technicalities, we have start with the presentation of Mark.
Well, I will adapt. Well, we're asking to talk about the future, but first of all, we need to look on what has been done, the achievement. And this is amazing because we have seen some of the information during this meeting, but I would like to say that we did an amazing thing during the 5 last years. Since it has been launched, NUTEC has been launched, especially in the marine monitoring. So this was our steps. Now we are almost in 2026, and we reach our objective. Basically, I will go straight to the numbers quickly, and then after I'll go to show you what's our plan for the next 5 years. So basically, it's a global collaboration, and we saw that around. Among the audience, there's some of our counterparts. Now we reach 102 member states joining NUTEC and 107 labs. We also have building capacities. We talk about capacities. more than 400 people have been trained through the initiative, and 32 projects have been built during these 5 years. I don't have the return on the screen, but it's okay. We talk about harmonization of the method. This is a unique aspect because we want to have the same comparison worldwide, and that's what we did. And we have two, right now we have two harmonized protocols. Yeah, I will take this. Easier. And this is really important because it's not our work, it's the work of the member state, and that's been highlighted by our expert this morning. We also have equipped labs, and that's an amazing achievement because we were able to procure 70 labs around the world. And we reached this point thanks to the activity, as you were saying, about this unified activity with the TC program and the NA department. We also have a unique lab that have been built through these initiatives, and this is an amazing place to realize this research, but also train people. Now, we saw earlier with the youth, we have 3 people that have been trained and have been showing that these are labs that is functional. And we do research, again, because science advances and we need to have a mature technology for our member states. So basically we do research by ourselves, but also with the member states. So among that, also one of the big achievements is about this network. This network is simple because the beauty of it is we strengthen global research collaboration. We also promote this harmonized protocol due to this network. We support member states with a specific target capacity building program, and we enhance the capacity around the different labs, 17 labs for now. But also, this which is important, I think, in the context of this NUTEC initiative, and especially in marine monitoring, what we do in fostering the knowledge exchange across the region. And this is the beauty of this network, is that there's an exchange. We saw with Remarco, this is how we do it. We have the exchange north-south, but also south-south, and this is really unique. One of the achievements that also we saw, it's about this platform, the data, because data are crucial, and we want to have a tool for the member states to provide, to store the data and to be able to report to the decision maker. And about the decision maker, the session yesterday showed that this is crucial. There's sometimes, and so too much often, a gap between the data produced by scientists and the policymaker. And this is why NUTEC is unique, because we are able to have a common approach. And this is why it showed the approach is perfect, because we have the common approach worldwide among the network. We also have a mature technology to share. And this is also the national reference. It's not us telling, we have experts in the country. Among our 107 member states and among the 107 laboratories in the NUTEC network, we have reference labs that we can trust with reliable data. And this is key. Again, this is also something I hope you have keep in your mind during these sessions and during these 2 days. We work toward indisputable data, because if you don't have indisputable data, it's really difficult to be able to inform policymakers. And finally, empowerment. This is really important in the IEA approach for the transfer of technology. I come to the future main priorities. Almost done. What is important for us, of course, 102 member states, part of these initiatives is great. But we don't want to stop there. We want to go further. And my colleague from the Philippines earlier said there's so countries that are not part of it, and we don't want anyone left behind. So we work toward enlarging our member state part of this initiative. What also, we want also to strengthen regional capacities. So we do national, but now we want to create these hubs, centers of excellence among the different regions of the IEA. This is key for us because we want this to be sustainable in the long term, and so therefore we want this expert center to be the reference for each of the region. Yeah, also, 2 harmonized method is not sufficient. We work on marine beach, which is important with microplastic. I mean microplastic, but the large one. We work on water, but we want to go further. Our DG talk about biota sediments, and we heard about the smaller plastic, which more harmful for the environment. This is where we're going, and we work toward that with our member states. We want to still boost the innovation. Okay, we talked about the mature technology. We want to go further. So the technology, the nuclear technology is important in the context of marine monitoring, but we want to go further in terms of how plastic degraded in environment, how macroplastic, for example, joining is degraded into smaller plastic. This is where we're going, and also going to the smaller and smaller. We talked about nanoplastic. This is where we're going. The tire, this is where we're going. So the technology is ready for that. We just need to develop that. Expand in partnership, because, of course, it's not something that we can do by ourselves. We invite an international organization. There's a lot of investment that is needed for going for the objective that we want. We want to work together with others. We don't want to be ourselves. And, of course, the member states also are trying to do themselves at the region scale, at the local scale, but we do it at an international scale. Finally, what is important for us, and this is a really important information, we want to drive the technical leadership. This is important. We are able, with our member states, not by ourselves, with our member states and our collaborators, we want to lead this fight to tackle marine microplastic. Thank you. Fine? Okay. We can hear you now.
Thank you very much, Mark. I now invite Selena.
Thank you very much. I'm sorry for the technical difficulties, and now we have the presentation. Yeah. So we are going to talk now in the upcycling component, in the, well, what are the pathways that we are envisioning from now and beyond. But first of all, I wanted to introduce a little bit of what was our understanding when we launched this NUTEC plastic initiative. We knew about the plastic life cycle and the issue that it has, how the pollution that is generated due to this life cycle, from even the issues on the fossil resources, on the landfill and incineration, on the mismanaged, on the plastic pollution, microplastic, PFAS, and other pollutants that are being generated. So the kind of contribution to the pollution are in different directions. That was the overview that we were considering from the beginning, and that's why it's so important that the IEA considering the different approach. That's why if we are considering this different source of pollutions, we considering with our internal team how we can provide some solution. And that's why is that we are having these two approach, the upcycling activity in the land, in mitigation at the source, how to convert the plastic waste into some valuable product, as well as creating alternative to the fossil base, as well as Mark has nicely presented just recently on the marine monitoring, creating a strong assessment overview and the characterization identification, as he has mentioned just recently. So these are the two main approach that the NUTEC Plastic Initiative has and has been addressing during these last 5 years. Now, with more focus on the upcycling activity, if we have a look on the life cycle assessment, on the life cycle of the plastic, if we see from the origin, that this is the oil-based sources. There is a high component on this still. It's 99% of the plastic are being produced on fossil-based sources, and only 8% is generated by bio-based sources, and there is still a large component a very small component on the percentage of the plastic that is being recycled, is where we are considering different approach also. How to enhance the use of biomass for alternative to the fossil base, enhancing the use of biomass for bio-based plastic, for example, or high-value additive. And the second approach is on when the plastic has been already generated and post-consumed, how to create value from this plastic waste. These are the two main approaches that in the upcycling component we are also working together. And of course, both components are considering the circular economy in order to make it efficient, the process, try to reduce the waste that is being generated, try to avoid, also optimize the process to avoid the emission of greenhouse gases, and etc. And how we are implementing our activity. And this is a summary, no, that how we are combining all the mechanisms the IEA has in place to contribute to achieve the goal that we have considering. We have research and development. This is IEA, one of the unique organizations that has research and development implementing, no, through their regular budget. So, and we are coordinated this research among different researchers among the world in order to compare results, harmonize protocols, and have very consistent and very strong results and science evidence, no, of what we need to define. Also, toolkit, as has been presented this morning, no, on the economical, in the theoretical approach, and etc. Capacity building, cooperating through creating capacity building in the countries, and in the region, and at interregional level. And also, we are combining all these mechanisms in order to have a strong process, validate the technology, and advance and create the progress that is necessary to demonstrate that the technology is available and is viable, not to scale up and try to, well, introduce that and sell to the industry that they can considering that this technology can be really applied in the real environment. And of course, we are collaborating also with our others partnership, no? Our collaborating center, other research centers, also a standardization organization, etc. And these are the two main areas as a summary of the countries that are participating, no? Both in the biomass utilization for bio-based products and also in the recycling of plastic, no? To create structural and non-structural material. And under this CRP, Coordinated Research Project, is that we have also developed and validate that the technology is really achieving the result that we were expecting. And in the biomass, what we are producing, no, in this area is green chemical, high-value additives from biomass, other bio-based plastic that are replacing, no, the fossil-based product, and also biofuel. And in the case of the other component on upcycling of plastic that has been already generating, we are, well, developing together with the different researchers around the world the high-value product from e-waste, wood plastic composite, as has been shown also today, and also we will see in the house in the PNRI, and also fuel and additive, as has been presented today in the morning, and also concrete, light concrete, where we are replacing the cement by recycling plastic. No, that is the cement is one of the industries that are generating one of the bigger, no, greenhouse gases emission. And now we have been talking a lot about the theoretical, the technology readiness level approach, and we follow this scale to define where the country are progressing and where is the status and what is the way forward, no? And all of them are considering the same language, the same roadmap, and we are going from the idea, the conceptual idea, to the commercial application, and we have success story, as has been presented today in the morning, Indonesia developing this touch, Argentina developing the railroads, Philippines developing these bricks and tile for the house, and Malaysia developing fuel from the plastic waste. So these are the success story, and where they are, well, in the prototype level, that this is between 4 and TRL 4 and TRL 5. So the maturity of this technology is quite advanced and is close to became a pilot scale plan. Now, considering the future, where we are going, well, this year, what we have done is start testing. I'm talking about the team that is working on the upcycling component, is testing the material that has been generated in the real environment. We launched the circular assessment tool. Enrico has presented today, very good. We have this high-level forum for dissemination, for achievement, for networking, partnership, and also we are continue now assessing and using this tool to validate that how we are really obtaining good result, good data from the application of this tool. So this means how the technology is really reaching the circular economy. And in the way forward, beyond the 2025, we will continue, of course, developing the technology. As Mark has mentioned, we also are planning to have like a reference country that are developing these pilots in order to serve as a reference and model for the other countries that want to learn about this. So this will facilitate and probably speed up the process. We are planning to enhance some research and development, especially in areas that we identified that there is a gap, such as in the case of chemical recycling, radiation-assisted chemical recycling. Why? Because this can treat mixed plastic, and this is hard to recycle by other technology. So there is an opportunity, and it has been proved by the Malaysia team that they are achieving very good results there. And also, we want to continue validating the tools that we are developing. It's not just a matter of launching the tool, it has to be proved, tested, and improved. And this is something that we will continue working on that. The bio-based innovation, we are at the lab scale on this area. We want to scale up the technology, make the bio-based product in a large scale. And this is the opportunity to try to replace the reliance on the fossil-based plastic. And, the deployment stage. We want to develop all the guidelines and roadmap that are needed for those countries that has achieved the pilot on deploying the technology and going ahead on with a commercial application of the technology. And with that, I'm done. Thank you very much.
Well, I thank now Mark and Selena for sharing their perspectives. We have heard now both dimensions, NUTEC plastics. Allow me to highlight that as we advance priorities, the IAEA Technical Cooperation Program will continue playing a crucial role in delivering NUTEC plastics-related services per state by way of capacity building, technology transfer, or other support in terms of building partnerships, as has been emphasized by our director. Since the launch of NUTEC Plastics, 39 technical cooperation projects have been developed and under implementation. From this, 7 are projects supporting cycling, and 32 projects are supporting the marine monitoring component. As we move now to 2026-2027 cycle, we have enormous opportunity to strengthen and expand the mainstreaming of NUTEC plastic support to our member states. As you have heard also, there are expressed new interests. Regions like Africa are also taking up serious steps in terms of participating. Through this new cycle projects, agency will continue accompanying member states, bridging the gaps, building key partnership to support science translates into meaningful, measurable, and sustainable solutions. Well, I think with this, I will now transit to the intervention of our distinguished guests. Ms. Yoko Watanabe, Director of Environment from Asian Development Bank, will share us her perspectives on opportunities for collaboration. You may address either from your seats or from here as you prefer.
Wonderful, thank you very much. It's an honor to be here and representing Asian Development Bank and sharing some perspective. I guess it's been a very productive 2 days for hearing all of you, the success stories of how you have been grappling with the plastic pollutions and innovative solutions around it. And we heard on the first day at the opening from President Marcos and my own President, President Kanda, that really plastic pollution is a really emerging issue within Asia and Pacific in particular, really having a strong health as well as ocean health issues. And we really need to tackle this very quickly unless there is going to be a lot of problems within the ecosystem in the nature side as well as human side in terms of our health. And as you have heard many times, I mean, this is not a foreign issue. And in you know, just next door within Philippines, where I also live right now, the 1.7 million tons of, you know, plastic pollution every year is a real figure. And also, I live in Rockwell, and the Pasig River is next door, and we know that this is a source of 6% of the plastic that goes into the world ocean. And we really need to tackle this issue very quickly. And in that regard, I want to share some perspective from the Asian Development Bank side, what we are doing at the regional as well as country, and also at the local level, and also give some perspective of what can we do together moving forward. So in terms of what we are doing, we just approved our new Environment Action Plan, which my team and across ADB is committed to really address the triple planetary crisis that we face today. The triple planetary crisis is the biodiversity loss, the pollution, which the plastic pollution really squarely comes in, and then the climate change, of course, and nature-based solution is a really key sort of solution towards that as well. So Asian Development Bank really committed ourselves to working under the pollution pillar to work on circular economy and plastic management as a sort of a start. And I want to actually emphasize here that working on plastic is not just working on plastic management at the sort of entail of it, but we really need to work from source to sea and really work on the 3 principles of circular economy of reduce as a first step, and then reuse, and then go towards recycle, because we tend to actually, you know, tackle the last part, recycling and waste management. And that's where we have been in ADB spending more investment, but we're more looking into how can we come up with more alternative, or how can we come up with reducing and reusing these technology so that we can really have a circular economy and a circular economy approach towards it. And so in terms of what we're doing, first of all, that's a global, sort of a regional level. We committed ourselves under the Environmental Action Plan, but that has been translated at the country level. So we work in 40+ countries in Asia and Pacific, and for example, in Philippines, the country strategy squarely notes about the circular economic growth and how we want to really tackle this issue on the ground. And that translated into many different initiatives, but I just want to highlight 2 of them. One is the Pasig River plastic waste digital twin prototype. This was also highlighted by my president yesterday, but this was to simulate basically the Pasig River and see where the source of the plastics are coming, and then where it's actually trapped, so that we can come up with a solution on a pinpoint basis, not as a sort of aggregated level, but by having a simulation on the screen, we're able to really see, using the satellite and other data, that where the waste is coming from and how we can solve the issue. And so we just, launched that and transferred to the government 2 weeks ago. And we're really owning this together and, really happy that the stakeholders are really starting to use this technology. Another thing is technology is one thing, but unless there is a finance and unless there is a governance attached to it, we're not able to, solve this complex issue. So the finance side of the issue, we are working on currently to be a $1 billion investment on circular economy and plastic management on the ground in Philippines. And actually this is built on the project that we approved in Indonesia last year on a similar scale to reduce marine debris and also stimulate more blue economy, meaning fisheries and tourism and other initiatives so that there is alternative and also economic growth attached to it. So we're really looking forward to having this as a sort of a significant financial sources as a policy lending modality to the government so that we can tackle this issue on the ground. And finally, I also wanted to highlight that we have a technical assistance program at the regional level, working right now in 4 countries in Philippines, Sri Lanka, and Vietnam, and Thailand, but also try to expand this so that we can work on it not only on the technology area, but also on the action plan, and also a strategy at the country level or a subnational level, so that we can really tackle the plastic issues as well as how we can promote circular economy in the countries. And finally, I think moving forward, with ADB and IAEA, we already have a memorandum of agreement working on agriculture issues because food system, as you rightly mentioned, is really threatened by microplastics and other issues. And we can also use nuclear technology to prolong the food sort of sustainability and others. So I think the positive and also the negative can be also tackled together through strengthening the food system. Another thing is we think that by applying the technology that you have started with monitoring the microplastic, we could use that for health issue as well, because we are really seeing that microplastics are coming into our body, and we should be tracking and also seeing how we can be utilizing this technology in a medical science as well. And maybe those are the areas that we need to look at it further as we move forward. And finally, I just want to highlight that, doing all these things, we need 2 things. An integrated approach among all stakeholders. None of, like government or private sector alone cannot work with this. Civil society, local communities really need to come in, and then institutions like ours to enable and support that is also a really important part of this sort of stakeholder mapping to support on plastic and circular economy. And finally, also an integrated approach. We can't be, working on just plastic issue as a plastic, but we need to look at it from the ocean health, the health issues, and also economic issue, and integrate actually these costs of plastic really into our economic model, because unless we do that, we will be using the take and make and waste sort of model forever, and that cannot really solve the issue. So we really need to look into the economic model that we live in, put the natural capital into our economic modeling, and be able to move forward with a more circular economy. So with that word, thank you very much for inviting us, and looking forward to our partnership further. Thank you.
Thank you very much, Ms. Watanabe, for the excellent insights you shared with us. In the framework of the Cooperative Framework Agreement that IAEA concluded with the Asian Development Bank, we definitely will continue our dialogue, and we extend our exploratory discussions, concretize specific partnership. In this regard, we'll continue with our proposals, as well as we'll also further our discussion in the broader areas of environmental management and specifically plastics management, plastics waste management. Thank you very much, and I now move to invite Undersecretary Lea Bonlea, who will provide us insights on the national innovative pathways in the Philippines and the ongoing cooperation for activities. You may wish to address either from your seat or
ladies and gentlemen. For the past 2 days that we have been together, I think this international forum has underscored the urgency of collective action and the promise of nuclear technology to address global plastic crisis. With said earlier, there has been about 20 million tons of waste coming over to the oceans, to the environment, affecting every aspect of life, not only in the Philippines, but across borders. And only 9% is being recycled. So you see where this other percentage goes. It's either in the fish, in our stomach, in the environment. And so this is very, very alarming. But it's also clear that there are very ingenious people who can work together to solve the crisis. And these are not actually isolated efforts, because we see that through IAEA and through the initiatives of the different member states, there has been a lot of technologies developed, a lot of initiatives done. The only thing is, it should not be in our laboratories alone. There is a need to put it out to society. There is a need to scale up the technologies. And there is a need for people to adopt these technologies. In fact, this is the only solution that science be used to combat plastic pollution and protect the environment. I'm happy also to note that in this forum, the youth has been involved. And there is a very big potential when we put our efforts and our investments to the young people. They will be the next leaders. They will be the next people sitting in front of us. And they will be the next people who will learn on how to combat crises like plastic. This forum also brought perspectives of the policymakers. In fact, even as high as the president himself has been very interested in solving these kinds of problems. The academia present here has also provided some insights on how we will be able to solve the plastic pollution. The industry, outlining both the challenges and the opportunities in tackling our plastic waste. And the Philippines has invested a lot of funds for research. Considering that one of our eight big ticket program is on circular economy, we have been very much aware of these kinds of situation in the Philippines. Marine pollution was also highlighted as a global crisis which requires international organizations to provide coordination, harmonized methodologies, comparable and shared databases, and stronger monitoring system from the coastlines to the seafloor. I think the monitoring system is very vital since plastics, when it goes to the ocean, does not see any borders. It is not from one country, but it will transfer to any country where the waves bring them. So monitoring should be, one, cost efficient, and open, we'll be using open data platforms so that everybody can have access to it and use the data in order to monitor such. Earlier today, we restarted the forum with sessions on innovative plastic upcycling technologies. And this is how we saw composites and advanced chemical recycling to construction materials. So these are new products out of plastic. Construction materials and improved sorting technologies, which demonstrates also how radiation can boost performance and efficiency across the value chain. We also emphasized, while we underscore the need to increase monitoring capacities in the region, we need also to contribute to global data sets. So please, do not keep your data to yourselves alone. There is a need for us to contribute to the wider global data sets so that everybody can have access to this data and everybody can have that initiative in order to use this data in order to have solutions for these plastic pollutions. We're also able to see earlier on this morning the project under the NUTEC program of IAEA, the house built out of plastic. And this is very promising, considering also that when we touch the house, it's very firm, can withstand storms, wherein the Philippines are visited, in the Philippines is visited by an average of 20 storms in a year. So this will be very promising when it comes to housing problems in the Philippines. And while these 2 days demonstrated that the challenges is immense, the combination of science, financing, policy, and youth engagement offers a clear pathway towards scalable global solutions. So together, the challenge is, let us transform science, policy, and partnerships into lasting solutions to build a cleaner, more sustainable world, not for us alone, but for the generations to come. Thank you very much.
Well, I thank you very much, Undersecretary Bundia, for the very inspiring message, excellent summary of the perspectives in the Philippines. Excellencies, distinguished participants and colleagues. Well, presentations, the reflections, and the shared perspectives this afternoon underscore key and important message for the future of tech plastic. I would like to summarize this key message, take-home message, under 5 categories. First, we have heard about the agency and member states continued focus on advancing radiation-based solutions for plastics waste management, supported by clear technological pathways under a structure. In this regard, the message is we accelerate. We enhance our efforts and we accelerate to achieve feasible, technologically sound, as well as scalable solution member states benefit. In different presentations, interventions, we were also reminded harmonized scientific data, research networks, shared methodologies are essential, ensuring our interventions remain evidence-based, globally comparable. The information for and actionable. This regard, the message that we had across the board is we enhance. We also saw the importance of partnership, financial, technical, strategic partnership to address this global challenge. The key message that we have is we build, we maintain, we harness the merits of partnership. As the forum actually comes to conclusion, we are all encouraged to maintain the spirit of collaboration, shared commitment, and this was also the message that resounded in the House. Takeoff from here is we keep the momentum. The future of NUTEC Plastics will depend on sustained collective effort for science, policy, partnership, and program delivery. My summary from here is energize and well, with this, we conclude the summary session. I would like to thank our speakers for sharing us their perspectives and all participants for your patience and active engagement. We'll continue working together, and I thank you all. I now pass to Master of Ceremony for handling the session for closing remarks. Thank you very much.
Thank you so much to our moderator, Mr. Gashao Wald, our speakers, Ms. Selina Horak, Mr. Mark Betian, Ms. Yoko Watanabe, and Ms. Leia J. Buendia. Once again, ladies and gentlemen, our moderator and our distinguished speakers. Let us give them a warm round of applause. To formally close today's program, we invite Honorable Leia J. Buendia, Undersecretary for Research and Development of the Department of Science and Technology of the Republic of the Philippines, and Ms. Zanka Kokaluva, Director of the IAEA, Division of Physical and Chemical Sciences, to deliver the closing remarks. Let us give them a warm round of applause.
Good afternoon, everyone. Do you still have the energy after this 2 days workshop? So, Excellencies and distinguished delegates, colleagues, ladies and gentlemen, magandang hapon po sa ating lahat, or good afternoon to everyone. As we close this international high-level forum on NUTEC plastics, allow me to express on behalf of the Department of Science and Technology and the Philippine government our sincere appreciation to the International Atomic Energy Agency and to all member states, partners, and experts who joined us in this meaningful 2 days. I would also like to thank and congratulate the Philippine Department of Foreign Affairs and the Department of Science and Technology in close collaboration with the IAEA for the successful organization of this high-level gathering. Your leadership, coordination, and shared commitment have made this forum a milestone. Let's give a big hand to these agencies, please. Our discussions from innovative upcycling technologies to harmonized microplastics monitoring showed the growing strength of NUTEC Plastics as a global platform for solutions. We heard not only from scientists and policymakers, but also from young leaders who spoke during the Youth's Voices on Plastic Solutions session. Their clarity, passion, and urgency remind us that sustainable solutions must include the next generation who will inherit both the burden and the opportunity to shape a cleaner future. A key message has emerged. We must scale up. Scaling up means transforming pilot projects into industries, integrating science-based monitoring into national policies, and ensuring that capacity-building efforts reach more laboratories, communities, and regions. It is also a means of expanding partnerships because the plastics challenge is too big for any country to face alone. For the Philippines, initiatives such as PREX and other broader circular economy programs reflect how plastic waste can become durable, valuable products when supported by science, investment, and strong collaboration. The PREX prototype house you have seen earlier is a powerful example of how local innovation can be scaled into real-world applications. Allow me to share 3 final reflections. First, innovation must be rooted in local contexts. Technologies succeed when they fit the realities of the communities they serve. Second, partnerships are indispensable. Scaling up requires shared ownership among governments, industries, scientists, and international partners. And third, people remain our greatest asset, not AI. Strengthening our scientists, laboratories, our youth, and innovators will define the resilience of our environment and economic future. Above all, this forum has shown that science, when guided by cooperation and purpose, can inspire hope and drive transformation. NUTEC Plastics is not just the program. It is a growing global involvement and movement for sustainability, circularity, and environmental responsibility. As we close, let us build on the momentum created here in Manila. Let us scale up our initiatives, deepen our cooperation, and continue harnessing the power of nuclear science and technology for a cleaner, safer, and more sustainable world. Maraming salamat po. Thank you very much and good afternoon.
Excellencies, distinguished delegates, ladies and gentlemen. As we conclude this high-level forum, let us reflect on the remarkable journey we have shared. From the inspiring opening remarks of our Director General, Rafael Mariano Grossi, who reaffirmed the IAEA's commitment to innovation and sustainability, to the powerful message delivered by His Excellency, the President of the Philippines, calling for bold and united action, this forum has set a clear direction for global collaboration. The areas of plastic pollution or combating plastic pollution where the radiation technology can play a role and has a really vital role to play, and also our ways ahead and what lays in front of the future of NUTEC initiative as well, has been very clearly outlined by the last session speakers and also my esteemed colleague before me. So allow me, before we conclude this event, simply to express my deepest gratitude to our host organization and the government of the Philippines for their leadership and vision in co-organizing this forum. Maraming salamat po. Thank you very much. I would like also to thank the IAEA team and also all panelists whose dedication and professionalism have made this event a success. Inspired by our young generation or youth generation session this afternoon, I would like to conclude the event using some of the words of our Director General. Innovation is not an option. It is our responsibility to ensure a better world for future generations. Let us make this responsibility our shared mission. Thank you very much. The forum is closed.
Thank you so much, Ms. Buendia and Ms. Cocalupa. At this point, we would like to announce first that to those who are interested to joining PREX Prototype House Visit, buses will leave at 4:40 p.m. and the assembly time or assembly point is at the Marina Way. Once again, to those who would like to join the PREX Prototype House Visit, buses will leave at 4:40 p.m. and the assembly point is at the Marina Way. Ladies and gentlemen, that concludes the IAEA International High-Level Forum on NUTEC Plastics. Thank you so much. And please enjoy this video that we have prepared for you as you pass this venue. Take a look at the screen.
Excellencies, delegates, ladies and gentlemen, welcome to the International High-Level Forum on NUTEC Plastics. I am pleased to see colleagues, decision makers, scientists, civil servants, and entrepreneurs gathered here today. This unity comes at a crucial time when only collective effort can address one of the defining challenges of the century.
The fact that the IAEA decided to launch this project 5 years ago was because we were aware that given the dimension of the problem, we needed to put our science, our technology at the service of a solution, a very concrete solution.
Plastic pollution is a global crisis and one of the fastest growing environmental threats facing our planet. South Africa is taking part in this process of developing a legally binding agreement that will help reduce plastic waste and promote a more sustainable future for all.
The Philippines is honored to convene this high-level forum at a moment when nations are redefining how science and technology shape their development trajectories. Across the world, environmental pressures are converging with rapid technological change. Leadership today demands not only political will, but an ability to integrate scientific evidence, cutting-edge research, and strategic foresight into national and global decision-making.
We believe that this forum will provide a valuable platform for discussing the solution and strengthening partnership to address these critical challenges.
The IEA, I like to say, is an international organization that is a service. It's a service to its member states who put their money into it, their trust into it. And this is the way to go about our business, by delivering, by giving back.
With the IAEA, we launched the NUTEC Plastics Investment and Partnership Brochure, which outlines pathways for governments, industries, research agencies to scale up investment in nuclear science for environmental protection and for industry growth. Science does not progress in isolation. It advances through networks of regulators, scientists, investors, community stakeholders, and the Philippines is committed to building such networks locally and across all borders. Our work in NUTEC Plastics complements our broader cooperation with the IAEA in food and water security, health, agriculture, energy, and disaster resilience.
For us, when materials improves, recycling expands, and rivers and oceans stay cleaner. For global challenges, local solutions. Let's get together to work together. Thank you.
Together, we are advancing a common goal. We want to convert plastic wastes, some of them irradiated with the electron beam, into high-quality construction materials. And after we've converted them, we want to deploy these materials in real structures. Most importantly, we would like to ensure that at the end of their useful service life of these construction materials, that they can be recycled again with minimal complications.
Let us move forward with clarity, with confidence and scientific ambition, so that future generations inherit a world where technology protects the environment, strengthens economies, and expands opportunities for all. Thank you, and I wish everyone a productive conference. Good morning.
Thank you so much, ladies and gentlemen, and please enjoy the rest of the evening. Thank you.